Okay, I've started the recording, so welcome everybody. Tonight is the 2nd of January, the first meeting of 2024. Looks like we're off to a bang with a great
group here tonight already to get started. We'll do the usual.
We'll do the usual as we do at DPRG and just go around the table with updates on our projects or questions, mostly related to robots, mechatronics, and things like that. Also, sometimes fun but amusing, distracting tangents. We have a few started tonight with John, Anuya, Cooper, Paul, and then open mic. So with that, I would say, John, feel free to take it away.
Okay. I have a couple walking robots that I've been working on lately. This one is my older one. It's a Bioloid, uses Dynamixel AX12 servos. It's got a Raspberry Pi Zero on it. 16 servos in total. A lot of 3D printed parts. It's got a custom head that has 5 little time-of-flight scanners on it. It's got a 9-axis IMU and a down-facing optical flow sensor and a camera, which I haven't started using yet. And it walks using inverse kinematics. I've got some videos, but I'll show that later. This is the one I'm working on. This is a biped walker. I first built one of these back in about 2007, but couldn't get the ankle servos to work properly. They just weren't strong enough to hold it up. But I saw a neat video last month from Disney, their Droids in Training video, and it introduced an interesting idea that if you don't have a flat foot, if you have a rounded foot profile on the bottom, you don't really need an ankle roll servo at all. And so I'm trying that out, see if that works. So far, pretty good. It's the same setup, Bioloid AX12 servos, Raspberry Pi Zero. It'll have a 9-axis IMU mounted underneath it, and both of these run off of 3S LiPo batteries, which are mounted underneath. So just a second, let me put it back on its stand. I've only got about 2 weeks of work into that guy. Let me share my screen. Can I share my screen?
You should be allowed to.
You should be allowed to. Yeah.
Yeah. I just had to touch the right thing. Okay. So I'll show this is a video of Roz. Is it? There it goes. Doing walking. So it's doing real-time inverse kinematics for the walking. Right here is running Python on the Raspberry Pi Zero. I've switched it to running Smalltalk, which is a language I used to use a long time ago, and I'm back to using again. So it basically walks around. This is autonomous. It's avoiding stuff using the LiDAR sensors and trying not to walk into things and whatnot. Can everybody see that okay?
Oh yeah, that's cool.
This is a short little video showing the LiDAR scanner. I do basically a 45-degree sweep with the head, right there. And then it goes back again. And I show at the end of the video here, I show this is what I get out of that. Whoops, that was supposed to stop. So it keeps disappearing. There we go. So this is it basically I'm using 3 of the scanners, the one on the left, the one on the right, and the one facing straight ahead, and I do a 45-degree sweep, which gives me a 270-degree sweep based on those 3 sensors. And you can see here it's measuring out to, this is in millimeters, so it's measuring out to like a meter. If it goes any further than a meter, it just ignores it, but it shows you where things are that are sort of in front of the robot. So it's a slow form of one of those 2D rotating LiDAR scans. So the other thing I've got, let me find the make sure this actually, yeah, there we go. So this is Microraptor standing up and then sitting back down again. So that's kind of cool. And then here's a quick video showing I implemented some inverse kinematics of it walking, just using a simple gait. So yeah, still lots of work to do on it, on both the software and the hardware side, but that's kind of where we are.
Is the Raptor using a depth camera? Is that what we
Yeah, so it has an Oak D light. I don't know if you can see it there, but this is the, it has an Oak D light. So that's going to be used for obstacle detection. The nice thing about the Oak D light is you basically set up a pipeline using Depth AI, and you can, it basically pushes the pipeline into the sensor itself, and it does all the heavy stereo vision stuff in the sensor. And then you can basically just get back metadata without having to get back frames. So the Raspberry Pi Zero can do depth analysis at like 30 frames a second from the metadata from the Oak D light. So that's something I'm looking forward to getting started playing with.
Very cool.
Yeah, and I use some co-processors on these. My quad walker inside the head, I've got an STM, basically an ARM Cortex M4, one of these little boards from Adafruit. That runs MicroPython, which is, I don't know how many people have heard of MicroPython, but it basically runs Python on the metal, which is very cool. And I can actually do a little demo of that. This is another board that runs MicroPython. This is a Raspberry Pi Pico, one of the RP2040s from Seed Studio. So it's very tiny, and plug it in, and it's running something right now that cycles the RGB. And here, should have kept sharing my screen. And so if we look at here, I can go into RShell, which is a neat little utility. And this basically gives me access to the folder that I'm in right now, but I can also look at the Pi board. So this is the folder sort of on the flash drive of this little device. And the program that's running on there, find my text editor, is this, and I don't know if you can see that very well. That font's probably really small. Let me see if I can switch to a decent size font here. Font, I'll go up to like a 16-point font or something. So basically, it has a WS2812, which is one of those little strip RGB LEDs. So it basically just imports that. It sets up a pin, creates the LED object from that pin, and then basically just tells it to fill in each of these colors. And it cycles through those. So if I go, and one of the really cool things about MicroPython is you can actually get a read evaluate print loop in MicroPython. So I'm actually, this command line that I'm running here is running on this chip. It has a Python interpreter built into the firmware on the chip. And so I can do something like reboot it, and now you can see it's printing beautiful colors as it cycles through the different colors. And if I go and change this so that I want to see, let's see, I'll just edit it like that. So just add something to the text here. We get out of, here, and I can basically copy main.py to the Py board, and then go back into the read evaluate print loop, reboot it, and now you see it's running beautiful colors by John. So it's a really nice way to do embedded work. And of course, you got full access to all of the hardware features of the chip. You've got KWMs and analog to digitals and UARTs and SPI and I2C and all of that stuff is, plus of course the whatever GPIOs and this little board, it's an ESP. Well, this one's an RP2040. I have another one here, which is also a Seed Studio board that has an ESP32 S3 on it. It's got 8 megabytes of RAM and 8 megabytes of flash, Wi-Fi, Bluetooth, and runs MicroPython. So that's kind of cool too. So I really like MicroPython. It makes life in embedded programming a lot simpler than having to deal with Arduinos and C programming and stuff like that. So if anybody has any questions about MicroPython or stuff that I'm doing here.
You had mentioned that one of your boards was using the STM32?
Yeah. This board here. This is from Adafruit.
How's your experience been with that? I've been working on a circuit all day, and I was looking at possibly using one of those STM32s, but I just trying to program the raw chip, getting the bootloader on there or otherwise seemed really...
It's trivially simple.
Really?
Yeah. So to get the bootloader, you basically there'll be like a boot. Some of them have a boot button, like this little board here, the RP2040. You can see it's got 2 buttons there. Next with the LED in between. Well, one of those buttons is the reset button. The other one's the boot button. So if you push the boot button and hold it while USB, you're in bootloader mode. That's it.
I'm with the raw chip from the factory. Sorry.
Okay, but you've put it on a board, right?
Not yet. I'm still in the circuit design phase.
Oh, okay. Well, I mean, I've designed boards for the 405 as well. So you basically, there's a line called B0, which is the boot, and if you pull that high to 3.3 volts and plug in the USB, it goes into bootloader. The bootloader's built into the hardware.
Oh, really?
Oh yeah, no, and that's what makes it so fantastic. And then you can use DFUtil to program it, and it's really simple.
Cool. I'll look into that. Thank you so much.
Yeah, if you have any questions, let me know. Is there an actual chat here? Oh, there it is.
Yeah.
I'll throw my email address into the chat, and you can send me an email if you have questions or whatever. And Tom, wherever you disappeared to there, send me an email as well. We should get together at some point. You're muted, Tom.
There's now 3 of us Canadians in this organization.
Yeah, where does Pat live?
Pat lives in Espanola. So halfway between Sudbury and Sault Ste. Marie.
Oh, wow. That's a long ways away.
He has family in Toronto, so he was
Yeah.
at my place last week.
Okay. I'm in London, which is a lot closer to Hamilton than that. So,
Gold star for John.
I'm
Thanks.
Canadian too.
Sorry, who is?
I'm Canadian too. This is Corinne.
Iron Rain. Okay.
This is Corinne.
cool. Yeah, there's also a group of us in Kitchener who are into robotics. So I can put you in touch with them too if you're interested.
Sure. You're aware of the Ottawa Robotics Group?
Yeah, they have a meetup with the Vancouver guys. I just found
Yes,
out.
I thought I recognized your name. I think you've been on that one before?
I know a bunch of the guys in the Ottawa Robotics Group, but I used to live in Ottawa a long time ago. Yeah, I don't think I've been on one of their evening chats, but
Okay.
I used to post on their email list a lot.
So I've been to Niagara Falls a few times, and I honeymooned Ottawa and Algonquin. Can I be an honorary Canadian?
Probably.
You gotta say a
Probably.
boot club.
A dude.
Yeah.
Hey, John, which time of flight sensors did you use? Were they Palulu's or?
They're the ones from Palalu. Yeah. They're
Okay.
they're the VL, the mid-range ones, the ones that go up to 2 meters.
Okay.
So yeah, I use those. I mean, I have a bunch of other ones now that I bought off Ali that are like way cheaper, and we'll see how they work for other robots. But I'm going to try with my biped. I call it Microraptor. I'm going to try and just use the depth, the Oak D light camera, as my sort of only vision range sensor type thing. And go from there. I have a new head that I'm designing for it that the Oak D light attaches to, and then it's got a big box here that I can stick this guy in, because I'm going to have the down-facing optical flow sensor hanging off that board, and then I've got a this is a funky little LCD panel. It's basically a 1.47 inch color LCD from WaveShare, although this particular one, I don't remember where I got this one, but I just ordered WaveShares from Robot Shop, and it's like 320 by 172, so it's crazy high resolution, and SPI interface, and I've got a MicroPython driver for it, so I'm going to put that on the top of the head so I can display like what the voltage is and you know, whatever it's doing and that sort of thing.
The time of flight sensors that you use, do you have I2C interfaces to them, or are they the ones that output like a pulse width? And...
No, they're I2C.
Okay.
So this chip here, so I've got a 9-axis IMU in the head that is also I2C, and then I've got the 5 time of flight sensors. Now, they're a real pain in the butt to set up via I2C. You basically have to have a shutdown line for each sensor, and you shut all 5, because they all come up with the same ID on the bus. So you have to assert the shutdown line on all 5 of them, and then bring them up one at a time and change their ID to a different value, each as all part of the initialization sequence, which is doable, but it's just a pain.
You could have used a MUX, right? I2C MUX too.
Yeah, I could have, but they have the whole thing there. So and I've got lots of I/O available on this chip, so on this board. So I just hooked up the 5 shutdown lines, and then the IMU is also I2C, and then the optical flow sensor is actually SPI. So it's basically that one board running MicroPython is talking to all of those things, and it's also and the reason why I used a 405 is I don't know if you guys have ever used the AX12 servos from Bioloid or from Robotis. They're basically a digital smart servo and they run off a serial bus instead of using PWM like a normal hobby servo. And so you daisy chain them. So each servo just gets connected. They have two connectors on the back, and each servo just gets daisy chained along, and that is power, ground, and the signal. And it's a serial signal. It's a half duplex serial signal that runs at a megabit. But you can build your own boards, your own devices that you can put on the bus. And I have two of them on this robot. This one in the head, and then there's another one. I have another one of those boards, and it's kind of hard to see because it's got a bunch of wires on top of it. But there's a board here that I designed along with my brother that does power switching. And one of the things that is really annoying about robots nowadays that run off batteries, especially if you use lipos like I do, and I use 3S lipos because these servos all run at 12 volts. So I use a 12 volt battery, but when I'm sitting on the bench here writing code and working on things, I don't want it running the battery down. So I want to plug it in from plug in a wall 12 volt adapter. But you don't want to be charging your lipo on your robot from a wall socket. That's just a really bad idea. So it turns out that I think Linear makes this neat chip called the LT4412, which basically allows you to switch between two sources, a wall power and a battery power. And it's not based on a diode, so it doesn't matter what the relative voltages are. If you plug in wall power, it switches to wall power and isolates the battery. And then when you pull it out, it switches immediately back to the battery. And the cool thing is, of course, I'm running a Raspberry Pi on this thing, so it takes, a couple minutes to boot up, and you don't want to be constantly booting it when you're development. But that switcher will switch it from battery to wall without rebooting the Raspberry Pi. So that's kind of handy. So we designed a board. This is an empty one that I have. It basically has the LT4412 on it and the ARM Cortex M4 board and a whole bunch of connectors and stuff. And it allows me to plug into the wall and then unplug it again. Hot plug, basically. So that's kind of cool.
Yeah, I do the same thing, but I use one of those ideal diodes that you can get off the web.
Yeah.
That works really well. Just kind of the same idea as what you're talking about.
Does it work if your battery's at like 12.6 volts and your wall power's only at 12 volts?
No, your wall.
Okay.
It'll drain your battery down to 12 volts.
So this one doesn't care about the voltage.
Okay. Yeah.
So it when you plug in wall power, it runs off wall power. It doesn't matter what the battery voltage is.
Right.
So that's kind of nice. I'm going to try and probably design a simpler one that I'm going to put on the biped here to do the same thing, maybe as a Raspberry Pi Zero hat. I think that would be really kind of cool to have that kind of plug-in capability on a Pi Zero to work that way.
Hey, John, someone had posted in chat questioning about the cost of those servos.
Oh.
And I bet if you had a link, I bet people would appreciate that if you didn't mind.
Yeah, so if you just search for Violoid AX12, and the company is Robotus, and you can. I have no idea what they cost in the U.S. They're not like crazy expensive. But they're, so let's see who's selling them now. Trosson Robotics sells them for $50 US. So they're in that ballpark. I have a whole pile of them because of a couple of robotics projects I was working on about 15 years ago, and I bought like 3 or 4 kits, and as part of a contract I was working on, and I got to keep all the servos. So
Score. All right.
yeah, and they come with really nice brackets too, and so I use the brackets, but then I 3D print. I print everything in ABS, so it you can drill it and tap it and use machine screws to hold everything together and stuff. So that's kind of handy. This is a new body for the biped that is a little bit wider than the one that's on there now, to give me a little more space for the battery underneath.
Yeah, I've heard of some other companies that make, like traditional RC companies that make serial busable servos. It'd be interesting to compare these to those.
Yeah, so like I bought one of these off of AliExpress along with one of their little control boards. And it's interesting, but the problem is that these things max out, the serial connection maxes out at 115 too, as far as I can see. And when you've got to talk to 14 or 16 servos, you're going to take a long time to do that. And the other thing that the AX12 has that's really important is one of the commands it has is called sync write. And the idea with sync write, it's basically a packet language that you use to send over the serial port to all of the servos. So like my quad walker here has 16 servos. And so I send a command that has embedded in that command the position that I want each of those servos to be at. And the ID that I send it out to is a broadcast ID. And so they all receive that command, and they all parse their own specific ID out of that packet and their own specific position, and they all change positions at the same time, which is really cool and useful when you're doing things like, this guy has 12 servos in the legs, so you want them all to be changing at the same time. So having commands like that is really helpful. And they're smart servos, so you can ask them for their position. You can ask them you can set the speed that you want it to go. You can switch it from, these are 300-degree servos, so you can control them. I think it's either 270 or 300, I forget. Or you can switch a software switch and change them to continuous rotation. You can ask for the temperature. You can ask for the bus voltage. There's a whole pile of parameters you can set on them. They're neat little servos, and like I said, they run off 12 volts, which is really handy, because then you can just run them off a 3S LiPo, and it works really well. And I have a little, unfortunately you can't buy these anymore. The guy who made them doesn't make them anymore, but this is a USB to Bioloid bus converter. It basically gives you on the Raspberry Pi, it gives you a virtual COM port, which you just open up at a megabit, and then you can just start sending stuff over the bus. So you can get bigger versions of this from various companies, but I like this one because it's really tiny.
Oh wow! It even looks like Mauser has them. Mauser's based. They have a shop within driving distance of some of us here in Dallas. So.
Oh, cool.
Yeah. Actually, a sponsor of DPRG, I think, at times. So yeah. Yeah, I'll list Mauser.
Yeah. So yeah, they're really handy, and as I said, you can build your own devices to interface, and you can. I mean, you don't have to use an ARM chip. You can a bunch of the, like this is one I built a long time ago. This little board, this has got an ATmega 168 on it, and that's basically a bus device that I can just plug in, and I can talk to sensors that are attached to this. So those are kind of neat. So for instance, this one here is one that I built and I built these like 15 years ago, and it allows you to use these little force sensitive, these FSR variable resistor type things. They're pressure sensors basically. You can push on them, and they give you an analog value. And so I can plug 4 of those into one of these little boards, and that's what I'm doing on the biped. I've got space for 3 of them on the foot, and so hopefully that will help out with balance. And so I can basically just put one of those boards in the foot here, and then daisy chain off the last servo to that board, and I can get the values directly in the Raspberry Pi from that without needing to add any other interfaces or hardware or anything. So that's really convenient.
Very cool. Well, thanks for sharing. That's fantastic. Neat stuff. The Gold Star. So I don't know if you're familiar with the club habits or not, but when people demo things live, working robots, there's one of our guys started giving gold stars before. So we continue that. Feels good, whatever age you are, whatever grade school thing you're in. We give out gold stars, so enjoy. You earned it. Well earned.
Thanks.
Okay, so and we'll remove your. We'll make a note and remove. We share the chat with the recordings and stuff, but we'll pull your email out so it's not posted on the website.
I don't care.
Okay. All right. Cool. Next up, we have Anuya, and then Cooper, then Paul, then Open Mic.
Hi, I'm Anuya. I'm part of Iron Rain. You've probably seen me present here before, and I'm just going to do a quick recap of what our season's been like so far, what we're working on right now design-wise, and just ask you guys for any advice you might have and any input you guys want to give. So, I know one of my teammates was here a couple of weeks ago, but I don't know if he explained the game to you this year, so has the game or like the point of the game been explained, or should I just go ahead and do that?
Is this game the one that has where you're stacking some sort of box, some sort of block against a wall, and it has like a stack? I think he's explained that one to us.
Yeah, so the game is basically put pixels on a backdrop. So you pick up a hexagonal shaped pixel, and you stack it on a backdrop, which is essentially like a board at an angle where the pixels will fall, and you can make certain patterns with them, and you get extra points for doing so, and then you get extra points for putting certain colors places, and that's just the way the game works. And obviously, as Iron Rain, we came up with a incredibly convoluted way to do it. So I'm going to run through what we've been working on so far and show you guys what we're doing right now.
Cool.
Let me share my screen. Cool. So, FTC Center Stage, this is our progress. So, we started off with Robot in 2 days, where we basically... Can you guys hear me, by the way?
Yes, yes, we can hear you.
Thank you. So, we started with Robot in 2 days, which is essentially where we learn what the game is, and we decide we have 2 days to figure out how to put this bare minimum skeleton of a robot together and see what goals we're trying to solve. And we realized what we need to have is we need to have an intake. We need to be able to transfer from that intake to an outtake, and we need to be able to deposit with that outtake on the backdrop. And that outtake needs to be able to deposit from multiple heights, because we need to be able to stack the pixels higher and higher as more layers are created, essentially.
So you couldn't go to the top and let them slide down, or they'd pop out, right?
We can, but if you don't have a certain level of accuracy, they will pop out. But it's at a low enough of an angle that you have a lot of leeway. But we didn't want to necessarily risk it, so we wanted to have that level of control in our outtake. So in our robot in 2 days, we used a old claw from last year's robot, which is that carbon fiber and Ninja Flex portion you see there. And we created a Scoopagon, which is essentially a little plate, which is the white and plastic section here, which is essentially a little plate where the pixels would slot into, and using that you deposit it onto the backdrop. And we learned some important things from this. We realized that, so this year we were allowed to pick up 2 pixels at a time as opposed to 1 element at a time as per usual. So we realized our intake should have the option to pick up 2 things, and our transfer and outtake should have the option to control those 2 things separately. So from here, we moved on to the next iteration. So this is basically V1 of our robot, and if you ever want to watch our robot in 2D videos, it's on the QR code right there. So this is robot V2, the robot we are currently working with, and this is the purple pixel eater. So basically this robot has a sort of upgraded beater bar system, which is the red Ninja Flex right here, and it takes in 2 pixels, which slot into the Scoopagon here, and then they are deposited using this linear slide and hinge mechanism. And this is almost entirely rev rails. We have sky hooks here, which are how we're going to hang on to the rigging. So one portion of the game, which I completely forgot to mention, is that in end game, or the last 30 seconds of the game, there's a section where you can hang on to a part of the where you can hang on to, sorry?
Part of the arena.
Hang on to a part of the arena. And so the way we're doing that right now is we have these hooks which kind of latch on to the rigging, and we lift the robot up with servos. We were initially going to do a completely different mechanism, but this is what we're doing currently, and that's how the robot works as of right now. Except we have plans for the robot which involve completely changing the chassis, turning it into carbon fiber, optimizing the spacing, cleaning up the wire management because it's a bit of a disaster, and just all in all optimizing how the robot works. So that's what we're working on right now. We've had 2 iterations of the intake so far. So the first iteration, we realized that we really only need 1 vaguely small intake system in the middle and 2 beater bars on the outside, so we could intake from a very wide angle, and our drivers would have to have less accuracy. So one thing about our intake is it needs to be hinged because it needs to be able to pick up from the pixel stack, which is a stack of 5 pixels, and it also needs to be able to pick up these pixels from the ground. So we created this initial version of the intake where we had these little side walls which the pixels would feed into. However, we realized that we really didn't need a mouth this big, and it'd be easier if both of the pixels were being intaked at the same time, so it wouldn't be a mess when it came to the actual Scoopagon, which we call that little tray. This version also really didn't have many allowances for error, and we didn't get a chance to test it out because we moved on to the second iteration of the intake, where we have two belts side by side, and they're operated by an internal motor attached to an internal plate. And the interesting thing about this version of intake is that there are diverters which are attached to these little mini servos on the side, which I'm circling right here. And basically that allows you to decide which side of the Scoopagon a pixel is going to. And it basically just gave us far more control of what we're intaking, and it let us pick the colors of the pixels, the way the pixels are set up, etc. And it just gave us better control. And by switching to a carbon fiber version instead of the RevRail version, which you see here, we'd be able to optimize the space a lot more, because while FTC has an 18 by 18 by 18 inch rule for the robots, this year's game, the rigging is at like 14 inches, while the other entrances are at 11 inches, so we have a lot more limitations for height if we want to be convenient.
It seems though that that's awful dependent on you coming up against two pixels that just happen to be next to each other or something like that. Is that a common thing?
So there are two ways the pixels can be picked up. So there's the pixel stacks, and there are these things called wings. And if I can pull up a center stage, if I can pull up what it looks like, it'll be far easier to explain. So this is what I was talking about. So these little red and blue areas are the rigging, and these diagonal lines are called the wings, where we have a human player or person who can deposit 2 pixels at a time into the wings, and they can deposit any color they want and in whatever configuration they want. And that's when we're going to be picking up 2 pixels at a time. And here, these are the pixel stacks where the robot is expected to pick up pixels, if that makes more sense.
Okay.
And these are the 2 ways we're going to be picking the pixels, and we know that our intake works hinged, and we have enough control over that through our drivers, and we've tested that out and seen it.
Okay.
So these are the iterations of the intake, and as of right now, this has been catted, and it is quote-unquote complete, but now I'm going to show you what else we've been working on. So this is, once again, intake, and I'm just going to show you how different aspects work. For example, the diverters, we have little L-beams which are attached to servos, and they rotate, so if a pixel is inserted, it can be manually moved from one side to the other. And we've tested it, and we've seen that as of right now, it is working effectively, and we want to see if our coders can make it as functional as possible. And this belt design is a design we used a couple years ago, where we had a ring evader, and we had to take these orange rings up and deposit them somewhere. So this is taking inspiration from a previous design, but we had to adjust the beater belt lengths so they'd be smaller and they'd be better for the pixels.
Okay, so I might have missed something initially. So the actual travel path is underneath this red belt and above the black backplate. That's where the pixels go in?
Yes, the pixels go in underneath the belt, above the backplate, and then they get transferred to the Scoopagon.
Okay, which is just the shaped holder. Yeah, the shaped holder.
And using that in a linear slide, they're moved onto the backdrop, which is this situation over here.
Right. Gotcha.
So the next thing that we are currently working on is the nacelles, which is basically where the wheels are mounted, the motors are mounted for the wheels, and where our sky hooks are going to be operating from. I'm currently working on attaching the sky hook, so I just wanted to share progress with that. So as you can see in our previous design, our sky hooks are mounted right on the side of the robot. They're tensioned in place using they're kept in place using these bungee cords, and there's a pulley system which is holding it in place, a pulley and a spool. So what we're going to do is, in our current design, we're going to incorporate the same things, however, for more strength, and so they're holding better, because right now, they're not the most stable part of our robot, and they kind of need to be, because they're holding the entire weight of our robot up on that rigging.
Yeah.
We're going to be switching that out into 10 millimeter, we're switching them out to 10 millimeter rectangular carbon fiber tubes. And we're going to be using nylon casing to ensure that it's stable at the point where holes will be drilled into the carbon fiber tubing. And however, we've seen that the relationship between these two rev rails works pretty well right now, and we're going to try to maintain that relationship. However, the spool, which is currently controlling the movement of the movement of the sky hooks, isn't perfect, so I'm going to be seeing if I can work on that as well.
Okay.
So
it has two sky hooks, right? Those are the
Yes.
things on the end, and they just come up
two
and
sky
then
hooks on both sides.
pulls themselves up.
Right. Using
Okay.
two servos.
Gotcha.
Or actually, sorry, two core hex motors.
Okay, no, that was sound clear.
And that was my bad. And I can show you that right here. And I'm going to, quote unquote, turn off the outer side plate so you actually get visibility. So here we have the current assembly. These are the odometry pods, which we're using so the robot can maintain its location on the field. And we have our wheels here, which are the regular Rev 75mm mecanums. We're using two-stage ultraplanetary motors inside these motor mounts, which are shaped like shurikens so they can slot conveniently near the wheels, and we can have the shortest belts possible when they're tightened fully. And these slots are so the belts can be properly positioned. And here is... my laptop can barely handle running Zoom and, running Google Meet and Fusion at the same time, so this is taking a bit. And this is the spool where the string alongside the motor for the sky hooks will be. And currently I am working on attaching the sky hooks physically to this section of the robot so they can work in the Fusion model as well as on the actual robot, and then we will work on machining this entire subsystem and building V3 of our robot mainly out of carbon fiber.
Okay. I have a question because I know this is a little off topic, but I want to ask you before I forget. You guys work with a lot of the different interesting materials. Now, have you ever 3D printed the carbon fiber ABS, or excuse me, no, carbon fiber nylon? Have you guys messed with that at all? Yes or no?
I don't think we've experimented with carbon fiber nylon, not that I'm aware of. Mr. V, if there's something I don't know.
I think we did in one of the previous years.
Okay.
Okay, I was just wondering is it worth trying, or is it just one of those things that's a globby mess?
We have used it. It is the time when we were doing it on our robot, I think, or on our 3D printer, the nozzle heat control wasn't so good, and so I'm not sure if that's the reason. But we had really poor layer adhesion using carbon fiber infused nylon, and so it would tend to split. It is much more rigid coming straight out. It's also got a very rough surface. So, like, one of the things that the team often relies on with nylon parts is
slickness,
a low friction kind of surface that you can get with it. And so if you're using the carbon fiber infused stuff, you gotta sort of set that aside. That's a different different use case.
Okay.
So it seemed promising in most dimensions, but it was, for us, it was really bad with layer height. But we're going to revisit that as we keep moving forward.
Yeah.
Yeah, I've printed carbon fiber ABS. I print almost everything in just ABS, but I've printed some carbon fiber ABS, and I'm not that impressed. It's not a lot different from just regular ABS.
Okay. A lot more wear, I assume. You have to use steel nozzles or whatever?
Yeah, I had to get a hardened steel nozzle. I did pick up a spool of glass reinforced nylon, which is apparently nicer to work with than the carbon fiber reinforced nylon. So I'm going to try that at some point.
Okay, that's cool.
So
Okay.
As in fiberglass, then?
Yeah.
So I'm just coming from an aerospace industry. We are very particular in orientation of the fibers. In these type of 3D printers, I figure they're just chopped up materials. So I'd be surprised if they really lend anything to the structure.
Yeah,
it does stiffen it quite a bit. It's not as strong as real laminated, properly applied carbon fiber, but it does strengthen it.
Yeah.
So is it powder or is it filament? I mean, I've never used it. I've kind of stayed away from it just because of my background and.
No, it's a filament.
Filament with very short strands of carbon fiber infused in it.
Yeah.
Okay.
Now there is a company that makes a really expensive, like $6,000 or $8,000, FDM 3D printer that actually has a spool of carbon fiber thread, and it will lay down actual carbon fiber as part of the print process, and it makes phenomenally stiff parts.
Yeah.
But that's like big money, and the material is outrageously expensive for hobby use.
It's out of our price range, that's for sure.
Yeah.
Yeah, that kind of stuff is approaching what I'm used to in the aerospace industry. So that's
Okay, I'm sorry to throw you off like that. I was just, when you get old like me, when I get old like me, the thoughts don't stick in the brain very long, so you got to get them out or else. So please excuse my interruption.
Adhesion problems. Okay.
Yeah.
So
my layers delaminate.
Okay. Question. Anui, I've got a question for you. I noticed 3D Fusion in a pretty fancy-looking CAD design. Do you actually, how far do you go in the CAD modeling? Do you have the kind of parametric equations and physics modeling and weights and all that other stuff into the model?
I'm sure I could, but honestly, I don't know how. But if that's something I could probably definitely look into. But I know that Fusion itself isn't the best with real life adaptive modeling. Like, it doesn't account gravity into joints, etc. And I don't know if there's any way to do so. So I don't know how far I could go in Fusion specifically with that.
I was just thinking, from our point of view, because I know they can get pretty fancy, those tools, but I was just thinking from a basic point of view, and I'm a doubly more than a mechanical guy, but it seems that the interference checks and those kinds of design rule checks could be very handy. So I was just wondering if you did those kinds of things or just to visualize.
I'm not entirely sure if Fusion can do interference checks. I think I've looked into it, but it wasn't something I was able to look into. Like, jointing and tangential relationships in Fusion aren't as convenient as one would assume they should be. And a lot of it is eyeballing, seeing if it's working in the way you want it to, and Fusion won't tell you if two surfaces are connected in a way you want it to, so a lot of that is just trial and error and hoping.
Mm-hmm. Didn't you guys used to use another one instead of 360? Didn't you use what are they called? Solid something? SolidWorks?
They used Creo previously? PTC Creo.
Yeah.
And a lot of other teams use SolidWorks.
Predecessor for SolidWorks. They're the same company, I think.
Okay.
Yeah, they're just different generations.
Okay.
So, no, yeah. Sorry.
So you guys have moved to 360 basically.
Yeah, it works better with our CNC integration, right? Because
Yeah, I can see that. I can explain. Yeah, that's cool. Yeah, and you guys have a full license, right? Because of your team.
they get educational license free for high schoolers, and it has a lot of cool features in it, like I think some of the things, like I don't have access to it, but they have access to things like generative design and things like that.
Yeah, cool.
They can do stress analysis with that version.
Yeah. But as far as I know, or at least without some add-ons, the joints, it basically you can, when you join components together, they can run right through each other in ways that the physical world would not allow. So you do need to do a lot of manipulation to verify that it's moving in the right way and not slipping sideways and that kind of thing.
You have to add limits to it to keep that from happening.
Yeah.
So this is my first introduction. Are you a high school group?
Yes, sir.
Well, that's pretty impressive. I think this is quite sophisticated for a high school group.
Yeah, I should point out that these guys have gone to world champion competitions several times, so that it's not just a high school team. It's a good high school team, really good high school team.
Well, if you wouldn't have said so, I would have thought you were a college group. I mean, you were presented yourself in a way that was what I thought was very well. And
thank you very much.
The design is pretty sophisticated, and your command of the tools is good. Are you using ROS? No,
they don't use ROS. They're required to use an Android-based SDK and controller, and it does not support ROS.
Okay, but still, it's pretty impressive. I like that.
Yeah.
So I was just curious. I was looking over y'all's robot for this year, and I was noticing or I was rather curious what your plans to do teleoperation automation. I know in the past y'all have had state machines and whatnot do various tasks to automate some teleoperation routines, I suppose. Do y'all have any plans for that in the future?
You're asking the wrong person code questions.
There's no coder on the call tonight, so I'm sure we'll have a coder update y'all with progress and some actual video of the robot in operation. Not the version that Anuya is working on, because that'll be like their next version of a complete rebuild. With carbon fiber structure, but the current version of the robot is based on aluminum extrusion, the REV aluminum extrusion system. It doesn't look quite so nice, but it basically has the functionality in place. And I'll just sort of preview that I think they're going to take automation further than they've ever taken it before.
I'll stay tuned.
Yeah.
Also, I was just curious. I was reading up on the game here. Is anybody doing the paper drone?
We have a iteration of it, and we have an iteration of it. It's been tested off robot, but we haven't yet gotten it on robot. And we have one of our other designers working on that right now. So once they're done with it, we will add it to our fully built assembly, and one of us will be on to present it. But yes, the drone is definitely achievable. It's a glorified paper airplane.
Yeah.
Like in the rules, it basically says make a glorified paper airplane. But it's definitely achievable. The point system is also very interesting, but it's possible, and we're probably going to launch it either either right before we hang or as we hang from the rigging using our skyhooks.
So, I guess people have been doing it then. Have they just been going all over, just like out of the playing field, whole 9 yards? I feel like that's such a, I don't know, it's just wild.
In our league, I don't know if we've seen many examples of it happening, so I don't know if I'm the right person to ask about crazy stories related to said drone. But with our testing, or like with the limited testing we've been doing so far, if you get it to be accurate enough, because it's probably servo controlled, it's probably using tension or rubber band, something of the sorts, you can probably get it relatively accurate every single time, especially if your design of the paper airplane doesn't change.
And I've got one final question here. So, I had to step out for 2 seconds, but I had noticed that y'all got the skyhook design, and I was just curious why y'all weren't using like the one-way latch sort of thing, because I thought I remember seeing it. It was somewhat
one-way latch. I just can't. I didn't demonstrate it properly. If I think I can share my screen again really quick. Wait. Work.
Yeah, sorry about that. I'm pretty sure you did mention it.
I probably glossed over it, but if Fusion will function on my computer, it's having a bit of a rough day. But so this is our skyhook. Essentially, the way it works, like we said, Fusion isn't the best with realizing that things are touching and they shouldn't be going through each other, so it won't be the best, but it can go up, and then as it runs forward into the rigging, it'll snap itself back and lock itself into place using this pole right there. And it's worked. It's been working so far. We haven't. It hasn't officially worked, like in a official league meet of the sort, but we've seen it work. I saw it work like 4 hours ago. So let's see what happens with that one.
Do you have springs or something that puts tension on the pole, or?
That's being tensioned using a rubber band.
Oh. Okay.
So there's a rubber band tensioning the pole, and that's what's holding it in place.
Okay.
I don't have a good enough picture to show it off CAD, and CAD isn't the best.
Yeah, if you might want to look into on your Fusion 360 for those contact points, you might want to look at contact sets.
At what?
Contact sets.
Contact sets?
Yeah.
Okay. Can you put that in the chat, Brad, so that she knows exactly what it is?
Yeah, I think.
And if you got a link, that's even better.
It's on the Autodesk website, I think.
I think I've found it. Thank you so much. I've been trying to figure out how to do this for actual months, and I was getting nowhere.
That and joint limits. If they have a little tutorial on joint limits and contact.
I can do joint limits, but I've never used contact sets before, so that's going to be what I immediately look up after this call. Thank you so much.
Hey, I have just a dumb question. That red belt, is that something you print or just buy off the shelf?
It's printed out of NinjaFlex, and the way we have it made is it's 2 basically sheets of that material with like the ridges, and what we do is we kind of weld it together, and then we slip it onto an axle with sprockets, which is then controlled by motors. So that is printed out of NinjaFlex.
So you actually print, I would presume, a big flat thing with vertical fins?
Yes, and we then weld it together into the length we want it to be.
And NinjaFlex is sturdy enough that you can actually print the ribs? Like how tall?
Yes,
how tall is the print?
I don't know how tall it can print, but I can tell you that on this, it is printing a height of 15 millimeters.
Okay.
So just under 2 inches then?
No.
Half, a little over half, between half and 3/4 of an inch.
Yeah.
It can print.
15 millimeters?
Yes.
Yeah, okay. Sorry, I thought you said
And how
50-something.
thick are they, the little ribs?
They're 2 millimeters thick. I could be wrong.
Are they
I think they're
tapered?
1 millimeter thick, probably, or 1.5. I don't know.
No, they're 2.
2? Oh.
Yeah, we thickened it. We have the thick version and the thin version. I think the thin version might be 1.5 or something. But
You got the thin version on the robot right now. The thick ones were like so energetic that they were like knocking the pixels out of the Scoopagon.
Okay, a question on, since you brought it up. Okay, you said you welded the Ninja Flex. Is that essentially with a soldering iron type of a tool, or you know, I would have probably used created little rings like a hinge, and I would have stuck in a wire through it. So I'm just curious of how. So how are you welding it?
we did ours with a soldering iron. I'm pretty sure. Once again, I wasn't the one to do that, but Mr. V, correct me if I'm wrong.
That was Vance. Yeah, that's correct. But so the you'll notice that there's holes all the way through it. Did that show up on the design?
No, because
that's not the real printable version.
Yeah.
So they're basically these have holes, a grid of holes.
Yeah.
Because they are driven by sprockets.
Okay.
And so those holes need to not be occluded by like some special mechanism to sort of join two belts together.
Yeah.
Yeah.
So basically, you just melt it with a soldering iron then?
Yeah, that's how they do it. Vance did it for these systems this year. Yeah.
Okay, that's cool.
There's a jig that they print so that it aligns them, right? The holes fit into them, and then so that maintains the relationship between two belts as they're being joined together. And then, yeah, he's just drawing a hot soldering iron tip across it on both sides.
All right, cool.
How well do the fins hold up? Are they, prone to splitting or?
They're very tough.
We have seen a little bit of splitting, but I'm pretty sure that was just an issue with how we printed them, not with the fins themselves, because some of the fins will have split, but I'm pretty sure that was just like a small hole in the CAD somewhere. We haven't had to actively...
Oh, sorry. I was going to say they last up well past the time that they use them over the course of the game, so it typically is rugged enough.
So is that minutes or less
than
an hour?
I mean, like the season. Sorry.
Oh, the whole season. Oh, okay. Yeah.
So is Ninja Flex real similar to TPU? Is it a special formulation of TPU?
I don't know.
I think
it is a TPU. Yeah.
Yeah.
Okay. I've used TPU. I've never used Ninja Flex, so that's what I was asking.
It was one of the first that was commercially available. It's got a good reputation. In fact, it's sort of like the Xerox machine. So when you talk about TPU, you're often talking about Ninja Flex. Even though it might not really be Ninja Flex, it might be something else.
Well, the name brand
that may be more of a Dallas thing, right? So Ninja Flex was really popular at the Makerspace in Dallas, and that's when we first got. It was before the term TPU was out there a lot, and so a lot of us just sort of learned of TPU as Ninja Flex here locally.
If you guys don't have any more questions for me, I had a quick question for you.
What you got?
So we have a lot of people who are interested in design, and I wanted to know if you had any advice for someone who's just getting into CAD or somebody who's just getting into like the aspects of mechanical engineering. How do you put things together? How do you make it work? How do you not give up?
Oh, that's a big one.
That is a big one.
I think the only rule that I know about mechanical engineering is don't push on a rope. That's one of the key ones, I think. But
So is this an academic or just a hobby? So I'm a retired engineer. I have many decades of mechanical engineering, PhD. I was a mechanical engineer before I ever went to school. I tore things apart. Now, academically, that's a different story. I mean, are you asking academically or just kind of personal curiosity and hobbies and?
I think a combination of the two because I'm asking for like the entire design build team, everybody involved in our robotics program, except I'm speaking for all of them, I guess. But we're a high school team, but we compete, and I guess our program is like a feeder into engineering or into STEM degrees, etc. So I was wondering if you just had any advice on how not to give up and how to also take criticism.
Well, I think
you have to be open. You have to be open to criticisms because you get into the real world, you're going to be criticized.
Yeah.
And it's not to use, just making sure your design is sound and it doesn't fail. So thick skin, realize it's not against you, it's against just trying to make your design better. But I think the best hobbyists, the best engineers are hobby engineers. Like I say, I'm a retired engineer, but before I was ever educated, I was an engineer, and there's an aptitude there. I think the best engineers are engineers long before they ever go to school. It's a mindset. It's a interest. It's a personal pursuit. I don't know. I'm not sure this is really what you're asking or not. Not everybody is be happy. Not everybody would be happy to be an engineer. Be honest.
Yeah.
But if you're in this robotics group, I think you probably have already culled yourself out as being engineers. You guys have, like I said, these are for the high school group. I think this is a very impressive design, and you're taking it seriously. So I think you've made that first hurdle.
I think you hit on it perfectly. Don't give up. Just be persistent. Don't get discouraged. Don't take it personally, like for criticism of a design. And don't get discouraged if the first 100 things you try don't work, because the 101st one might.
Well, it's the Graham Bell. He invented so many things. He never saw a failure as a failure. It's just something that did not work. And you have to be an engineer. It's not because there's something internal to be an engineer. And you don't do it because of personal accolades. It's because of just the pursuit of the knowledge and the fun and getting your hands dirty and building things.
Yeah, also nowadays, you don't have to be trained to be an engineer. If you want to work at it for a living, you might want to. But like, I'm a software developer. I've been building hobby robots for 25 years, but everything I know about hardware and electronics and 3D printing and CAD and everything else associated with the stuff is stuff I've taught myself. I did software and computer science as a bachelor's degree, but nothing in hardware, no engineering, no nothing.
It's funny. I think the culture in this country seems to be going back in circles in a way, because I know in my dad's generation, whatever, he studied civil engineering in college, and then he somehow picked up metallurgy. Just I don't know how, because he happened to work in the research lab for U.S. Steel. Next thing you know, he's a metallurgy engineer. Then he's a welding engineer, and then he's consulting on bridge projects and all over the country and over the world. But that was before there was really degrees. So then for a few decades, college degrees seemed to take center stage, and now it seems like we're back to Oh shoot, my son-in-law, COVID came along, so his piano degree wasn't working so well for performance. So he taught himself software from Udemy for a year and landed a pretty cush job as a software guy, which is carrying him forward now. What I heard you say a couple times was like, don't a risk of giving up, and then people not maybe, I don't know, treating their ideas the way you intend them or something like that. And what I hear is that percent is that it might be something of that, like it just give yourself the time to figure out what really motivates you, what your passion really is, because it might surprise you to find that some of this stuff is cool, but like when I got into electronics, it was pretty cool, and I always thought when I went to school they were big on semiconductors, and I enjoyed that. But at the end of the day, over the years, I've discovered I have a lot more fun at the product level. I don't want to get down into the material science that it takes to build this, and the chemistry to make a good silicon wafer and nanoscale lithography. I have a lot more fun at the higher level, just grabbing boxes and parts that already work. And, well, okay, I shouldn't admit it, but making PowerPoints and how do people want to buy it. But, so I wouldn't say it's not about giving up to me. It's more about finding what your passion is, and then don't be afraid to chase it.
Yeah,
Don't be
I
cast
would.
with someone else's expectations.
I would add a few thoughts from because of where you guys are. You're high school students. And you're in a program that's very, very giving you a lot of advantages over, say, your fellow students. But so how can you maximize that? Don't waste your time on things that don't have a future for them, or don't, for example, like you're working on 360 CAD. That's a program that's well respected. You could get a job in a shop that's making 360 parts. There are other, I'm gonna make some people mad here. There's programs like FreeCAD, which is a good utility program, to get something that you can't do somewhere else to something else that you can't do. But it is not where you would want to spend your time becoming a FreeCAD expert when you had the option of becoming a Fusion 360 expert. Do you see what I'm saying? So pick your tools for where they can go in the future, not where you are right now. Because there will be a temptation sometimes, because something is easier, or for you just works better, to pick a program that doesn't have the future that these others do. Okay, so you might consider. And another thing that's very useful, and you said you didn't like criticism, but maybe I misunderstood that. But if you guys as a team can formally give yourselves product reviews or design reviews, where every time you say, I think it's ready, then you schedule a product review. And everybody goes in there trying to help, you know what I'm trying to say? But you'll get the advantage of all the minds of all your comrades. And ideally, that should help you make the next version better. Though at the time it can be somewhat painful, especially if you kind of did one of these, on the side. Well, and the magic happens, then that can get a little painful. But if you guys can formalize a form of review with your whole team, because let's admit it, I know most people, I hate to say it, are lone rangers. Okay, working in a team is very hard to do, and usually when they do it, when a team works, what they do is they segment it so that each person has their own little responsibility, and they're all lone rangers in their responsibility. So they're doing whatever they're doing without really input from the rest of the team. Okay, so like if you're building the skyhooks, for example, you're the only person building the skyhooks. There's nobody else looking at it because they got they're doing their own section. But if you can come in and have a review, say, okay, I think the skyhooks are ready, and have people go over it and say, well, why didn't you do this? Why didn't you do that? This looks weak, whatever. And show me how this is supposed to work. Those sort of questions and other questions that'll come up can be very, very beneficial to you.
That's real good practice too, because that's how it happens in the industry. And remember, it's not about you, it's about the product. It's trying to design a product that does not fail. And it's going to be critical. I think it's a very good product. Can you have a mock PDR, preliminary design review, or mock CDR, critical design review, and it's all about tearing it apart and making the best possible. That is really good, preparing you for the real industry, because you will be faced with that. And it's the first time that you've been into PDR or CDR, you'll be thrown for a loop if you've never experienced it before, because it can be traumatic if you've never dealt with it before.
And blow to the ego.
Yes.
Yeah,
but remember, it's not about you. It's not about the engineer or the student. It's about the design, because your responsibility as an engineer is to make a product that does not fail. And it's about the design. And it's about tearing it apart, finding the weak spots, fixing the weak spots so that once it relieves your group, it's a good product.
You should probably also get a better coach who's going to give you some positive reinforcement every once in a while.
I was going to say, so if we're done with all the real serious stuff, let me throw a couple of phrases at you, which kind of boils us down. That one is the level of your success proportionate to the number of times you say, screw it, I'll just figure it out. And the other one is engineers are our class of people I put in the realm of they're not smart enough to know they should have stopped two hours ago. To do that.
Hey, but Harold, that's actually, I mean, you put it in a funny light, but that actually reinforces what I was about to say in a different way, because part of the whole review thing is that, to Brendan's point, they're designed and intended to give you very valuable positive feedback. But what I've seen, and this was when I designed circuits for defense electronics like tanks and airplanes, there were some times when people just had, let's just say, egos. And they weren't really as concerned about the quality of the design as they were about, like, winning the argument.
Unfortunately, that's true.
Yep. It's terrible. And so the hard part is, in terms of not giving up, is that you have to like have faith in yourself and realize that sometimes you're going to get good, honest feedback, and sometimes you'll get just flat out jerks who are trying to be louder than you are and show you that they're better, even though they're often clueless. So
I think that's where the phrase, opinions are like assholes. Everybody has one, and some of them really stink.
I was trying to be clean in my little rant. And Ray goes and blows, and the wife over here is almost offended. I said almost. Okay.
Oh well, tell her.
She's proud of me that I didn't cuss words.
She won't be offended.
The mittens are off, but maybe that helps you out. Just don't take it personally, whatever it is, and have faith in yourself, because I think one thing you should take, if you take nothing else away from what you've heard tonight in Nuya, you have got some really strong capability, and it has shown in spades with your presentation, how you've handled yourself on this meet.
Yeah, I'm pretty certain there's a whole bunch of people on the planet doing the job that you think you should be doing right now or want to do that do not have the level of skill that you have and you've demonstrated in the last 30 minutes. Pretty much, I guarantee you that.
Thank you so much for all of your input. Unfortunately, my parents might kill me if I don't go eat dinner, so.
They win. Well, thanks for showing. So we appreciate it. Look forward to the next presentation.
Thank you.
Is our stuff still working?
And thanks for obviating my need to give any more positive reinforcement for the rest of the year.
They never said you can't be nice.
That was a strong positive reinforcement.
Did we mention you should listen to Kareem? Because if nothing else, you should listen to Kareem. But
I do that one every so often. It
every
happens.
now and then. Just don't let him know.
My bad.
See you later.
Thank you so much. Bye.
See y'all. Okay, that was cool. All right. We love Iron Rain. That's awesome. And speaking of that, so about a graduate, Cooper, I think we have you up next, then Paul, then open mic.
So can I ask, is this a mentoring type situation here with this group, this high school group? This is the first time I've seen them. Is it a mentoring group situation?
Well, I would say that DPRG is a solid mentor to the team because the team has presented multiple times over many years, and DPRG has always been very strong in providing them positive or constructive feedback.
And I think they've been in several teams, right? I mean, they have to graduate from high school, so yeah, younger kids come up and they're the team at that point.
The Iron Rain has been going for about 13 years now.
Yeah.
So none of the students who are in it now were in it originally, but yeah, it's just a thing that keeps happening. We're associated with the Science and Engineering Magnet High School in Dallas ISD.
Do we still have a majority of SEM kids, or is it all tag kids now?
There's a lot of tag kids now, so yeah, also from the same campus.
So what is that? SEM and tag?
SEM is a science and engineering magnet, and tag is talented and gifted students. They have a whole high school for themselves.
General purpose.
But so they have the one kid, he's trying to get into the school, and the door says pull, and he's pushing on it.
Brendan, you mentioned coaching, and I would say it's actually a two-way thing, because I think there's a bunch in the club who feel like me that long past school that and I get inspired when I see them, and I find some pretty cool ideas from the projects and their approaches to things.
No, I think that's college level project. I mean, they look good.
Mm-hmm.
Cool. Well, Cooper,
sorry,
what you got?
Yeah, so for those who don't know, I was on Iron Rain, but now I'm in college. I will say, it's funny that you mentioned that it's like a college level team. I've talked to the robotics team that competes in China at A&M. It's the same thing. I mean, really, they are really doing good work there at Iron Rain. It's always creativeness kind of distilled, if it were. And I don't know, it's really impressive what they're doing. But so if you don't mind, I might go into my project here. For those who have maybe not seen, oh man, here we go. For those who maybe have not seen my project, I'm working on a kind of mid-level robot controller. I wanted something that was a little bit above just plain RC, custom made, something like that. But I wanted something that was a little below, professional grade kind of controller solutions, or learning the entirety of ROS. As has been mentioned, I should just learn ROS, and I totally agree. But this doing it myself has really taught me a lot on that sort of kind of side of things, and I'll get into that a little bit later. This is the same presentation I gave a while back. Basically, this is
Cooper, you're not sharing the right thing.
Oh, my bad. Hold on here. And if I can't get this to share, just because I've got it on two different tabs here. One of these is my school tab.
Well, thank you for being proud of me, baby.
I'm very proud of you. I thought that was really good.
Here it is. Can y'all see that?
Yeah, that shows.
All right, perfect. So yeah, just as this is going on, it's basically like I want to make this controller because a lot of the times I get to a point kind of in the planning of my robots that I'm like, hey, I want a controller, but I don't really want to use some of the pre-made solutions. They're not really what I'm looking for, and I don't have the crayons or the time to learn ROS. So I just wanted to create this. I've had this as a project in mind for a very long time, and so I'm kind of getting quite far with it. So I had started up a design doc. Eventually, this will all be posted under the Creative Commons, though I need to learn a little bit more about that and get to a pretty substantial point, just about to be done before I release it. But I do have open source documentation, or design documentation, rather, going through kind of thought processes and why did I do this, why did I do that. I'm trying to keep kind of a log of what I'm thinking and, why I did the things I did. Maybe so that folks could go in there and be like, but also just, because it's a good kind of way to show, why I did the things I did. This was a very early picture that I did up, though it still holds true more or less, where you've got this controller on the right. That is a fully catted controller that I made about a year ago now, and it needs a revision, but it pretty much is the design that I've actually settled on to move forward with, more or less. At least the general, inputs and outputs are going to be just about the same. And then, you got your battery in your robot, you got your power supply and your robot kind of CPU, so to speak. Why do this at all? Blah, 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 blah. This is a test of it working. This uses ESP now. I'm using 2 ESP32s. And yeah. So I had done that, and then later on I had presented a robot working. I had a test platform based off of a Roomba, and it functioned. It worked as a controller, did the whole 9 yards, and it was great. Past that, I've actually added telemetry now. The system is robust enough to allow dynamic telemetry inputs. So once per loop, whatever you want to print, string or not string, float, int, Boolean, whole 9 yards. You print it out in your code, or your kind of user side code, and it just works, and it's great. It has dynamic packet dynamic packetizing of the telemetry data. It's got this and that. It's got all the bells and whistles, and it took me forever. And what I want to present tonight is the thing that I was really excited for after all that, which is designing anything that's not that. So I get to work on the electrical side of things, and what I wanted to present tonight was a kind of a dilemma. This is going to be in the design documentation, but somewhat of a design dilemma within this project. So on the controller side, I've got, all these different inputs, a potentiometer, linear potentiometers, joysticks, whole 9 yards. And I'm using these ESP32s. Let me get a better version of them. I'm using these ESP32s as the kind of main boards, right? So these are doing the bulk of all the processing, all the data packetizing, this, that, whole 9 yards, and the communication. And while I really like the full dev board, I actually, I've seen these little seed development boards for a while now, and this seemed to be just about the best solution that had an external antenna port, such that I could actually, kind of get better communication. And so I've got one of these for the controller and the robot side. And I didn't really think about it until just a while ago, but before even getting to the smaller board with way less GPIO, the ESP32, when it is using Wi-Fi, you can't use but 4 of the analog to digital converter pins. And so that presents a problem when I've got more than 4 things that I want to read, because I've got a, do I have it on my desk? I don't think so. Oh, yeah, here it is.
So for clarity, you said you can use the A to Ds if you're using Wi-Fi on a ESP32? Is that right? You can share pins or something?
Yeah, I suppose apparently the Wi-Fi module uses those pins. It's something I learned the hard way.
Yeah.
It really was a head scratcher.
It's good information. I was kind of working my way that direction myself.
Yeah, the A to Ds and the ESP aren't that great. I think they're not very linear, close to 0 and close to 3.3 volts. The curve's kind of almost like an S curve. But yeah, I had seen that, and it's just a restriction. There's a lot of other restrictions on pins too. I think if you have, or if you use the SD card, I think, or an SD card interface, I think 8 of the pins at the low, at the bottom end of the chip aren't usable because they're being used for that.
So if you're using Wi-Fi in a card, you're pretty much consumed all the pins, it sounds like.
It depends on the boards, but a lot of them, like the ESP32 has way more pins than what the little Seed Studio boards have. Yeah. And some of those things are hooked up to other pins that aren't brought out to like actual exposed pins.
Well, the reason why I asked is this controller board on this for the motors and the IMU is a ESP32. That's why I was asking. Didn't mean to side rail your discussion, but that caught my attention when you made that comment.
Yeah. So, on that board, do they bring the I/O out to vias that you can get to if they don't bring them to the edge connector?
On the seed boards, they're so tiny. I mean, just as a comparison, this is your ESP32, and this is the seed board. It is just about the size of the original package. And there's a couple exposed terminals on the back for different I/O and battery connections and that sort of thing, but there's just about no way you could fit even vias on this.
Well, I saw that they had some pads on the back. I'm just curious whether those actually go to other I/Os. And, in addition to the connections you have on the edge of the board, sometimes what I've done on boards that don't bring all the pins out is they will bring them to vias for test contacts. And you can, drop a wire into those sometimes and bring the I/O pin out yourself, if they don't. For some of those, that might be an option.
Yeah, actually, it's pins 6, 7, 8, 9, 10, and 11, and it's if you have external flash. Those are the pins that would connect to an external flash. So yeah, 6 of the pins go away if you have external flash.
So understandably, I'm at an impasse. I don't think that I could ostensibly use just the ESP32. So I had to make the design kind of leap to include a second microprocessor on the controller to do a couple of things. I mean, ostensibly, I could have used an I2C ADC, and I did look at that. I kind of reviewed all my options, but I wasn't super impressed with all of them. And besides just kind of the design limitations that I encountered, I have a bunch of digital read kind of stuff. I could do on an ADC, but it doesn't really fit the bill perfectly. Two, I I wanted to add kind of how do you say it? Redundancy. I wanted to add redundancy to the emergency stop button that I plan to include on my controller. Obviously, it's important to have redundancy for that sort of thing. So I'm actually planning to use a LoRa module. I should have had this pulled up, but it is the sorry about this. It is the
I don't know if you've probably heard of them. They're I2C port expanders. Yeah, so you can get up to 16 additional pins, either input or output. And some of the port expanders, it's configurable. You can make it either an input or an output. Some of them are fixed, but yeah, if it's just digital pins, that's a pretty simple way to do it. But
yeah, it's tough with the combination of both of them. It just seems like the best kind of the conclusion that I reached, at least, was using a separate microprocessor. Two, I wanted to incorporate one of these SX1276 LoRa chips. There's this I found that incorporates a lot of the stuff, kind of the integrated circuitry that you'd have to have around the bare IC, and that's all well and good, but it uses a SPI interface, and I didn't think it good to have the central kind of ESP32 running, all the communication stuff, all this, all that. So I kind of thought that it would be smart to delegate that to that separate IC or the separate microcontroller, just so that you can keep kind of the loop cycles or the loop time low to let the ESP now do its magic. And
Are you splitting off processes to the different processor cores? I mean, that's a way of that's one of the advantages of the ESP32. You have more than one core there. You could split up the. Are you taking full advantage of the capabilities there?
I totally agree. I am not taking full advantage of the capabilities there, but it's just tough because even if I did take use of that second core, I would then have to figure out still the I/O solution.
Yeah, I guess I was thinking you'd kind of do I/O on one core, and I'm assuming this is an autonomous system, right?
This is for a teleoperation remote controller, yeah.
Oh, okay. Never mind.
So it's like, it's tough because obviously we're the human is the limit here. So, you kind of design all this around loop cycles that kind of make sense for us, right? Like, it doesn't have to run at 16 megahertz because we can only observe, like 0.1 millisecond or whatever. So, I don't know. But so I spent a good portion of today working on this, which is kind of that idea of using the second microprocessor, and so I'm going to do that on a separate PCB here.
On your screen, Tom Cooper.
Oh man, I don't know why that is not letting me do that.
The automatic confounder.
Yeah. Here, would entire screen work?
Yep.
Usually.
Okay, yeah, fair enough. I guess I was clicking on
No.
Wrong screen.
Wrong screen?
Well, it's getting your meetup screen instead of the content screen.
It's just the participants inside of the participants inside the participants.
Reopen that right quick. All right.
Okay.
There you go. Score.
Perfect.
Schematic.
Yep. So, kind of, I was pulling, the kind of first big question was if there was any other way to go about this other than this. And I'm still totally open to looking at, using the extra cores, using that. If I can find a way to get enough I/O on the larger ESP32, this one would take up a considerable less space than a custom PCB. So, of course, it would make sense to look at that. I'm still reviewing my options on that, and I'm thankful for the feedback. But
your IO bottlenecks, that's what you're dealing with. It's just IO bottleneck, non-computational bottlenecks. Yeah.
Two, I heard SPI is pretty overhead heavy, though I'm not sure of where I heard that. In any case, so this is the kind of schematic that I've come up with this far. And essentially what this is the ESP32. This is the really tiny one, the seed one. It connects with the Atmega 32P. So an Arduino processor, an Arduino processor, such that I can just straight upload using an Arduino Uno as a bootloader or as an ISP. And I've got some, just really simple voltage regulation stuff going on down here to convert that 3.3 volts to the 5 volts for the Arduino Uno. Here is a bank of all the pins. So these are going to be JST connectors. I really wanted to try and find something that was a little bit more friendly for kind of plugging it in. So you're ostensibly only going to need to plug it in once. I'm trying to think ahead for like servicing it and this and that. I kind of want to make it, easy to do that.
Jim on the chat asked if you've wondered about the ESP32 S3 dev kit.
Let me take a look at that right quick. Was there a link in chat?
No, but I'm going to put one in there now. I found it.
So
here it is.
The Atmel device that you have on there, are you using that for I/O?
Yeah, it turns out, as you can see up here, I'm using every single I/O on the chip. Actually, I take that back. I'm missing one here, but it pretty well fits.
Okay. Do you have 2 pins on the ESP32?
Sorry?
Do you have 2 I/O pins that you can use?
Yeah. So I'm using the I2C line out on the ESP32, which is available during Wi-Fi.
Okay. Can you? What you could do is just connect up a serial. If you have, at least 2 unused IOs on each, you could basically just, use the UART and do soft serial between the Arduino and the ESP32, and basically pass whatever IO you want done to the Arduino to go do it if you wanted to do it that way.
I was thinking about using serial because I'd used it for the receiver board to communicate with the rest of the robot. I found it rather difficult, and I think that's maybe just a me issue. I thought it was kind of hard to kind of time everything. And in this case, I found it kind of more straightforward, rather, to have it where because you can kind of think that, this, the ESP32 is going to be running at, 240 megahertz. It's going crazy fast. The Atmega 32 8P is running at 16 megahertz. So I'm going to have some sort of buffer that fills up and switches every time that it becomes available, and it points to that whole 9 yards. Just because it's kind of like doing a bulk analog read, I was kind of looking for that leader-follower system, where the the ESP32 can just poll at any time when it gets to it in its clock cycle to just, grab what it can and, get back to it.
Yeah, you can do that, pretty easily through the serial ports with the interrupts. Basically you set it up to send a byte interrupt. Set it up for interrupts when the byte's sent. So you can do some things like that where you don't have to sit there and poll the devices. You can interrupt on the character buffer empty. So you can do things like that. And since the speeds you're talking about aren't that great, it should be fairly easy to do. Something you can do on a small device like that with just 2 pins, if that's the way you want to go. I don't know.
I really need to look into interrupts. I have not done that just quite yet, and it seems like a very powerful tool, but it's beyond me right now, I suppose.
Cooper, the other thing you can consider is the 328. You can run it at 3.3 volts. You don't need to run it at 5 volts. It runs perfectly fine at 3.3 volts. You can't run it at 16 megahertz. You can only run it at 8 megahertz. Yeah. But it's you can do almost anything at 8 megahertz, and you save yourself a lot of trouble of talking between the two chips if they're both at the same voltage.
Translators, yeah.
So you think that 8 megahertz would be fast enough? I kind of pulled it out of my butt that it should. Paul, one of the other times, talked to me about how to design this sort of stuff. And Paul, if you're listening to this, I just saw your email. I've not been I have not been trying to avoid you here, so I will get in touch very soon. But he kind of had this idea that he presented. When you're designing something, you put it in terms of, oh, this shall do this. And he had some really smart way of figuring out what those shalls were, and I'd still even though it's been quite a while, I've still not gone back and taken those notes about what makes that. So I was being kind of bad and half-assed about it, and I just kind of pulled that 16 megahertz out of my butt.
So the question you got to ask yourself is, how often do you want the ESP32 to poll the 18 mega 328? Do you want to run that at 10 hertz or 100 hertz or 1,000 hertz? For anything reasonable, you shouldn't need more. That's user interactions. You shouldn't need more than 10 hertz. For robotic stuff, I run my smaller robots that use embedded controllers at, I run the main loop at 100 hertz, and you could do that on a 1 megahertz machine, never mind an 8 megahertz machine. So, running at 10 hertz, you can do everything you need to do in probably, less than a millisecond, and then spend the other 99 milliseconds waiting for the next iteration of the loop, kind of thing. So, because none of this stuff takes long. You're basically just reading A to Ds and reading GPIOs and stuffing them in a table somewhere, and then the ESP32 sends a message over I2C or serial or UART or whatever. It doesn't matter how, and you respond with data back. The difference in the processor speed is irrelevant because you're using hardware ports to talk, whether it's I2C or a UART, and you're talking at a specific communication speed. If you were using I2C, you might talk at 400 kilohertz. And so, that's the communication speed that they both talk at, and it doesn't make any difference what the clock speeds are. It's...
So if I'm running it at 8 megahertz at 3.3 volts, thank you so much. Yeah, I'll take that and probably edit that tonight here. The one question I have in my mind is, let me just get through this a little further. So I've got the the power regulation and filtering stuff here. I've got just a quick and dirty, voltage regulator, the same one that was on the I2C ports. And, if I can take this out, then I will, definitely, because that would just simplify that, so much. But that runs into this LoRa module that also runs at 3.3 volts. So this would take, it would take out massive amounts of the circuitry.
Yeah.
But my main question is on the SPI line. I was planning to use the AVR ISCP, something like that. Here it is. The AVR ISCP.
To program it. Yeah, those will run at 3.3 as well.
So, but I had read that, and maybe I just need to buy one and figure it out. But I'd read that they don't run the data pins at 3 volts. They just use some sort of resistor to kind of cull the current in such a.
It doesn't matter because the I/O pins on the 328 are 5 volt tolerant, regardless of what you're running. So
I'm more worried
you can program them. Oh, I see. You're talking about because of the fact that the programmer uses SPI and that guy's on the same SPI bus. So what you want to make sure that you do is you put a pull down resistor on your chip select for the LoRa thing.
A pull down resistor?
Well, pull it whichever direction makes it so that it's not selected.
Yeah, okay.
And so then hopefully it will just ignore those lines entirely while you're programming the 328.
Okay.
And if it's really finicky about it, then you could probably just put a couple resistors in line on the three Mossy MISO and serial clock. I'm not sure if that would work or not. But I know that you can get AVR programmers that run at 3.3 volts. I'm pretty sure I have one here.
And if you have a link for that, that'd be great. Because
hey,
Clint.
Let me have a look.
I wanted to ask you a question. Have you worked out, typically the processors want to be an I2C bus master and talk to slave devices or slave sensors. Have you worked at that issue between the ESP32 and the 328P?
How do you mean?
I think both of them want to be master, and not unless you have specific code for, if you're polling the 328, it's also going to want to be master. So there's not, I don't know if there's a way to get it into slave mode. I know.
Yeah, the 328 has hardware I2C, and it'll do either. It'll do master or slave. Yeah.
I was sworn that was in the documentation.
Yeah.
Though I really need to check that. I will.
So this is a AVR programmer that I bought off AliExpress, and it has a header with a jumper, and in one position it's 5 volts, in the other position it's 3.3 volts.
Yeah. All right. Well,
this one will run either.
Atmel. Oh, the ice.
The ice, yeah.
I think I'd seen that somewhere.
But that one's kind of. I think that one's kind of pricey relative
to
the other ones.
The one I bought is cheap. It's
So now the other two questions I had, just while you're looking that up there, are as I had mentioned earlier, these are going to be on the board on the PCB, and they're going to be interfacing with I never showed this. It's a 3-axis joystick. It's got your typical two dimensions, and then it's got a rotational dimension, which I just thought was cool. James Bruton, I'm sure you all know, had it on his controllers. So I was like, wow, I thought that was super cool and maybe a little useful. So
I actually bought it on Amazon. That's the Amazon.ca link. You can just search for the product on Amazon.com if you're looking for it in the US.
Mm.
It has the 3.3 volt jumper.
Mm. All right, then I'll definitely take a look at that. So, out of curiosity, though, any other recommendations other than JST on these internal connections?
Sorry, JST for.
Yes,
easy connections. Yeah,
these are internal connections to the kind of the controller stuff. Like the buttons and the this and the that.
Okay, yeah. So, are you looking for a different kind of connection, or are you looking for other recommendations?
I'm just looking for other recommendations, seeing if anybody had any other perspectives on this. I really, in my mind, it would have been cool to have like a RJ10 sort of deal, but I definitely don't have enough space for that. And also that would drive up the price considerably for no good reason. So
yeah, so for small connectors, I use a company called Hyros. They have 1.25 millimeter connectors. So like this is a 3-pin connector. It's tiny, and they're nice because they have a positive detent. It's a Hyros DF13, and DigiKey sells them, which is the important part. And not only does DigiKey sell them, they also sell wires with pre-crimped terminals on the end, because it's really hard to crimp terminals that are that small. So for very reasonable prices, they'll sell you a bag of 10 wires with pre-crimped terminals. Yeah, that's the one, the DF13s. And so those ones are nice for a couple of reasons. Well, for 3 different reasons. One, they're really small compared to normal connectors, like 0.1-inch connectors. They're keyed, so you can't plug them in backwards. And they have a positive lock when they click together, so they don't just pull off easily. They take quite a bit of vibration and whatever without coming loose. And I use those on all of my boards for a lot of different things.
Cool. All right. Yeah, then I'll definitely look at that, especially with the pre-crimped connectors. I suck at that.
Yeah, well, I mean, it's really easy to crimp 0.1-inch. Like these are the Bioloid connectors. That's a 3-pin Bioloid connector, and it's really easy to crimp, those size wires. But the 1.25 millimeter ones are insane. And you need a special crimper that costs about $1,000 to do them. So,
yeah, as is. All right, perfect. Yeah. Then I guess the final question I had is, this is my second schematic I've ever made. I just was curious if y'all had any inputs on what I should kind of do to make it better in the future, because it's pretty all over the place.
Well, one thing you can do, you're running wires to a lot of components that you don't need to. It looks like. So one thing you can do to clean up the schematic is for your power and ground, or for your common, just use the signal lane to go between that instead of running the wires across. Like for your +5 and ground on your connectors there.
Yeah,
you're running lines. If you just run, a power and ground symbol, a power symbol next to that might clean it up, make it easier to follow.
Another thing you might try is you might look up hierarchical. I'm sorry, I'm saying it slightly wrong. Hierarchical. Thank you. Schematics. Is this KiCad or is this Eagle?
It's a KiCad.
Okay, it supports it. And once you figured it out how to do it, you'll use it on any project that's complex at all.
Yeah. So
And,
I'm just taking notes here.
yeah, the other thing you need to be really careful of when you have two microcontrollers like this on the same board is how you're actually powering the microcontrollers, especially the ESP32s have a USB plug on them, and you have to be careful because if you plug that in, then you're powering the microcontroller from USB, and if you're also powering it from the board level 3.3 volt, that can cause problems. So when you're programming the ESP32 over the USB, you need a way to disconnect the board power line that comes in, or be able to pull the ESP32 off the board completely in order to program it.
Yeah, I can socket it if that does turn out to be an issue. I believe I have enough room. The other thing is, I've got a diode here on the actual 5-volt line as per the documentation from Seed.
Yeah, that may be enough.
Okay.
But it's the 3.3 volt line. I mean, if you're powering this off of 5 volts on the board, then you're probably okay. But if you're switching your board to 3.3 volts, so you're basically not going to have 5 volts on the board, then you're going to be powering it from the 3.3 volt line and then plugging it into USB. So you need to make sure that that's okay.
Yeah. I guess I didn't really think about it, but I was just planning to power it from 5 volts from, whatever terminal, whatever that I was going to do, because this hooks up internally to that USB, whatchamacallit, and then everything else was going to be running off of this. Well, actually, I take that back. This needs to be changed out if I'm going to run everything else off it. I was going to run the ESP32 off the 5 volts, because I was going to take that in straight from the USB, power, whatever, or just buck boosted, 5 volt line from the battery. But then this was this is the just a bog standard linear voltage regulator. I chose linear just because I heard it was more clean power.
It depends on what current requirements. I mean, if you're just running the 2 microcontrollers, you don't need a lot of power. What I've started doing is using these things. This is from Palalu. It's like a 500 or 600 milliamp 3.3 volt regulator, but it's a switching regulator, and it allows you to you can run off like 30 volts or 12 volts or whatever, and it doesn't generate any heat, and it's much more efficient than the linear regulators. They're more expensive, but and they take up more space, but they just work, and you don't have to put any other components on, and it's so much easier. Especially like I run all my robots off 12 volts, like I said, and getting 12 volts down to 3.3 volts in a linear regulator, if you're trying to draw a bunch of current, it just generates lots of heat, and the switching regulators don't.
Yeah, all right. I'd heard with those switching regulators that because of the way they're filling up the capacitor and then they're kind of dropping off and then filling it back up and whatever, that noise can be kind of transferred through the power line or whatever rail you've got. And since this is going to be powering RF circuitry, I just figured in the data sheet it specifically mentioned like, hey, just have your power line be pretty clean. So I don't know.
You have enough bulk capacitors on the board? I saw a couple.
I don't know.
On the input side and output side.
Both you mean decoupling, because usually the bigger capacitors aren't quite as good as grabbing energy from high frequency transients, which is what make the switching regulators so efficient. And at the same time, when you have these microcontrollers, and if it's digital RF like we have in our phones, I mean, darn things are switching at gigahertz, right? I mean, the CPU is running at gigahertz RF frequencies. So you'll see very close to the chipsets for those kinds of systems, microprocessors and switching RF designs, you'll see those 100 nanofarad or whatever. You'll see really small capacitors very close to the power pins on the chips.
Yeah.
Yep.
And, that standard engineering answer, it all depends, right? So if your switcher is noisy, it's going to be a problem. If your switcher is quiet, you get away with it.
Yeah, it is. Especially if you're doing surface mount, like the 328 in surface mount, you definitely want to put a 0.1 microfarad ceramic capacitor at every ground power pin pair, like right next to the chip.
And that's why you'll find like those decoupling caps are ceramic, because they have good high frequency characteristics, but they're not very energy dense. So you'll find tantalums or whatever else, the big electrolytics for the bulk ones, because they store a lot of charge, except they let the high frequencies ripple on through. So you need both, depending on what problem you're trying to solve.
Or you can even do three, a 0.1, a 1, and a 10.
Yeah.
Yeah.
I've heard apparently on those high filter systems, so if you have a bunch of filtering capacitors on the at Mega 32 8P, I was reading through the whatchamacallit, the data sheet. On those, you have to enable something or other, and if you don't, then you could risk corrupting the EEPROM. So that's why I was maybe a little, I don't know. Is this not?
I've built literally hundreds of boards with 168s and 328s, and I have never taken any of that into account, and I've never ever had an issue with that kind of thing.
Okay.
So I mean, take it with a grain of salt, but this is like one of my 168 boards, and it has two ceramic caps. I've got a 0.1 and a 22 microfarad ceramic cap, because that was the biggest one I could find in surface mount, and a 0.1 decoupler, and then I've got a 0.1 on each side. This one actually has a linear regulator on it, but yeah, it's the thing you have to realize with data sheets and those guys is they tend to err on the side of caution, like way, way, way on the side of caution, for people that are building, really important things that can't ever fail.
Yeah.
In the hobby robotics world, we don't live in that world, and we just don't care that much.
We got different standards than a pacemaker.
Yeah.
Pop like it, it'll be all right.
I suppose I'm just new to all this, so I don't know what to write off and what not to. I'm kind of just playing it safe.
Well, here's another way you could look at it, kind of a practical way. Like a rule of thumb I use is that if I'm trying to deal with analog space signals, like before the A to D, and I really care about precision, I'll look at it with the scope, and if it's too noisy of a supply that I happen to be planning to use, then I'll grab a linear regulator locally. Otherwise, digital switching just wherever. But when I use that, I love the scope, because it tells you in real time, no matter what the data sheet says it's supposed to be, right? The scope will help you reveal what your wiring and your actual implementation of the chipset is. So I'll put the scope close to the thing that I'm worried about, and I'll just keep in my mind that that switching regulator is normally like this, but every now and then when I turn the motors on, I see a big spike. So I'll just keep that in mind, and then go about daily business. And then if if you stumble on one of those situations where something weird happens, then you've already got your mind set up to say, oh, I know that when that motor toggles, I get a big spike. When I throw this switch or when that contact closes, I get a big spike. And that's the voice of experience from a guy. So this was 1987. I did a test set for a laser rangefinder for a tank. And I had this interlock because the laser would fire a pulse of light that would burn a hole in the back of your eye. So when we were in the lab, we didn't want to burn out people's eyeballs. So but we had to make sure that the thing operated in a military environment, so over a broad range of temperatures and EMC and whatnot. So we had to put the unit under test in an environment chamber. So we'd run the temperature up and down, the humidity up and down. But the test set had to be outside because we didn't want to go to, we had to run it. And it didn't really have microcontrollers then. So I had this 20-foot cable from the test set over to the environmental chamber, and everything looked just fine. It worked great in the lab, right? Worked great on my desk. So we went to the test, and we were using this to acceptance test product that was getting sold to the military. Okay, and the test guys were reporting that every now and then they'd run the unit through, and it would get results that were just crazy, like way too many counts that it should for the distance estimation. I thought that couldn't happen. Well, sooner or later they caught it in action, and they drugged me down there. And at the end of the day, what it turned out to be was that the test set had TTL logic, and it just had this long cable, maybe twisted pair, but this 20-foot long cable to the environmental chamber hooked up to the interlock switch on the door. So whenever they closed the interlock on the door, that threw a spike over the TTL that didn't hurt the signal it was tucking to, but it caused something else to reset, and it screwed up the measurement. And it was just, real world one of those spikes. So I don't know what the lesson there is, except that it all depends. Just be aware.
Yeah. And the other piece of advice I'll give you is, I've been designing and building circuit boards with microcontrollers for many years, and I've basically stopped doing it now. It's just too much of a pain, and there's too many good boards out there already that are already pre-mounted, that you can surface mount the board that has the microcontroller. It's got all the needed capacitors and resistors and everything, built by real engineers who actually know what they're doing, hopefully. And it makes your life so much simpler if you stop putting microcontrollers on a board directly.
Yeah. That's my first time. That's my first time doing it. So I kind of figured I should learn. This is kind of the area to go into. So
great exercise.
It's a good thing to learn. What package are you planning using for your 328?
And it's a better thing to abandon.
I was looking at doing the SMD package, though. Realistically,
this is the package that I use most often. It's there's two different kinds. There's the ones that have the pins under the chip, and there's the ones that have the pins sticking out. I mean, they're both surface mount.
Yeah, I'm gonna have the ones with the pins sticking out, definitely.
Yeah, good choice. They are bigger, but they're enormously easier to troubleshoot and deal with the surface mount soldering and stuff.
Yeah.
Oh yeah, I could not imagine trying to work on systems with those with the SMD components that have the stuff on the bottom and all that. I mean, every time I saw the data sheets, I was just like, ugh.
And the other thing you're really going to want to do is get a stencil when you order your boards.
Yeah.
Definitely get a stencil. It makes a huge difference.
I've heard. I've seen people do this sort of stuff for like years because I watch YouTube videos on it and whatnot. But it's just like I've picked up bits and pieces from that. But I suppose kind of going through the process, I'm learning that I didn't pick up enough to say that I really know I'm not even. I don't know enough to even be dangerous. You know, I got some kind of design concepts or kind of.
It's a good experience.
Yeah.
We'll start there.
Yeah.
So
I can't see the components anymore, though. That's the problem.
And keep Park Super, you're all kinds of dangerous.
Oh, thank you. Yeah, I know. Talking about the whatchamacallit, the testing where you had some Carl, where you had some crazy test thing happen. It's nowhere near in scale maybe, but back in Iron Rain, every day was like that.
Oh yeah, that's how you learn.
Yeah.
Sorry.
Yeah. I never learned my lesson because I never got to the point where I could figure out how to test more efficiently. I just hit my head against a wall until somebody else came along that knew how to do it good, and he did it.
That's the thing. The people that like that turn it into a passion, and then that's the people you buy the boards from that have the microcontrollers already on them.
Yeah.
Yep.
Because they've hardened it for many real-world environments, the better ones.
I'm also trying to do all this, for the experience, but also just to show my college, because I've still got to get into the electrical engineering program. So if I document all this and I put it out there that I'm doing this for no other reason than I like it, maybe they'll actually let me in. So I don't know though.
Good stuff. You'll get there.
All right. Thank you.
Yep. Good
Yeah.
stuff.
Who's on the cube?
I think we had Paul next, and then
Good,
Mike.
I hope Paul's going to show his mug.
I actually have to take off, guys. It's 11 o'clock here, so.
All right. Well, thanks for coming. We hope to see you next time or sometime soon. And
Nice to meet you.
yeah.
Cool.
See you guys.
Cool prezzo.
Thanks.
So if you pin me, then you hopefully will see the mug big enough. On one side, on the outside, it's got the DPRG logo and robot, and the other side is a really cool image of the DPRG robot with some giant mountainous cones in the background. Little cones that he's about to stamp on. This is my winnings from Robo Columbus. And a little robot, little six-wheeled robot there that's proceeding in front of the DPRG robot. So inquiring minds want to know how Doug generated this image.
He got a designer to design it.
Oh.
I roughed out a little thing, and the designer made it much better.
Well, it's really nice. Anyway, we're very excited about that.
I'm hoping to have her design the next one for next year.
I don't know about anybody else, but I am ridiculously jealous. I mean, why in the world didn't I spend 6 months building a robot to get a mug?
Yeah,
that's an awesome mug.
Yeah.
So I've been.
I think Scott's got all three.
Last time
go
I
ahead.
had this meeting, I presented. I talked about my work with Docker, making a ROS Docker, because I'd upgraded my let me just share this. I'd upgraded my laptop to Ubuntu 22.04, so it wouldn't run ROS 1 anymore, but I still wanted to use ROS 1 because my robot's built on ROS 1. And so since then, I've proceeded to build Docker images for ROS 1 on. Are you guys seeing my?
I see a Docker, a ROS Dockers.
Yeah, okay. So the directory's in there. ROS 1 for RPi, ROS 1 for x86 Linux. You'll notice there's namespace there available for, and then ROS 2 on RPi and ROS 2 on x86 Linux. And you'll notice there's namespace available for ROS 2 on x86 Windows. should that come to pass. And all of those Dockers work. And so I'm just going to quickly show a couple of them. Let's see, let me just unshare that. And where's my mouse gone? Uh-oh, there we go. Unshare that and move over to, so the architecture of the, are you guys now seeing a ROS Docker architecture?
Yeah.
Yeah.
So this is the architecture of the Dockers. So it runs a Linux kernel, either Ubuntu on my laptop or Raspberry Pi OS on an RPi, and I've got it running on both Raspberry Pi 4 and the Raspberry Pi Zero 2W. And I'm using the Raspberry Pi OS because it's happiest on a Raspberry Pi, and or Raspberry Pis work best with the Raspberry Pi OS. So, for example, the Raspberry Pi 4 is hooked up to an SSD, and that you can do that. I couldn't make that happen when I tried to run Ubuntu on the Raspberry Pi, but it works fine with Raspberry Pi OS. So the way Dockers work is you have these layers of images. So they started off with Ubuntu 22.04 as a base container for ROS2, which contained Ubuntu binaries and libs and the bash shell and all that. They layered ROS Noetic for ROS1 or ROS Humble for ROS2, or the other releases that are available, and that contains ROS binaries and libs. And then I layer my programs, Mobot-related binaries and libs and packages, and they all run in the container, be it a ROS1 container or ROS2. It's defined as ROS1 or ROS2 based on the layer below it. And then I mount the Docker container mounts the host file system's workspace. So for ROS2, it mounts ~ROS2WS. For ROS1, it mounts ~catkin_WS. And then under there, you have the source and devel, all those workstations, which are mounted to appear inside of the Docker file system. So all the Docker programs see the source, and then they write the devel and build programs out to what they see as their file system, but it actually really ends up on the host. And the purpose of that is so that you can get rid of the container. After each instantiation of the container, I remove it and reinstantiate it from the image next time I want to run it. And all of that runs inside of a Linux laptop or a Raspberry Pi. And the idea, let's see, so switching gears here, I'm going to share a different window. Let's see. Window. Let's see, are you seeing a blue Tiger VNC window?
Resting.
So all of these Dockers, well, not the x86 ones because my laptop's got a monitor, but the RPi Docker images have a desktop and VNC to be able to look at the programs that are running, and I've got the prompts set up so that it tells you what it's running. Like this one's running ROS1 RPi, and it's in bag files, and so you can call up a ROS program RQT bag, and so this is running on the Raspberry Pi 4, and there's the bag file. This is actually the bag file from the Robo Columbus run. And in it, I discovered by zooming in to the packets as they're coming out, that this nav debug, I'm actually emitting a nav debug, multiple nav debug packets. So there's a bug in my program. So anyway, this is just by way of demonstrating that all the good ROS GUIness and logging and such is available on an RPi 4, and then I'm going to present an RPi 0 window, and so are you all seeing an orange sunset?
Yes.
So I'll run. So this is running the RPi ROS 2 Docker. So I'm going to run the TurtleSim node. So I've been going through the ROS 2 tutorials and learning ROS 2. And unfortunately, Harold left already. I was hoping to ask him how he was getting on with that. But while this is starting up, I am seeing the swap daemon run. So I had to increase the swap size on the RPi 0 in order to make it able to compile large C programs like libraries and such. But just to show that you can run this is running the ROS 2. I'm using the keyboard arrow keys here to drive the TurtleBot around in TurtleSim under ROS 2. So that's by way of demonstrating ROS 2 running on an RPi 0. Now, it's not, I'll be upfront and say it's not straight. It's not great in terms of responsiveness. I've been collecting performance data as I've been going, and so one of the things I found, some data I found was the RPi 4 can build Mobot software inside a container in 3.5 minutes. The RPi 0 took, I gave it a gigabyte of swap because otherwise it would hang. I gave it the -J1 option to use only one CPU to limit the amount of memory, because only having a 0.5 gig of RAM is really kind of small. And it took 88 minutes. Actually, it took 101 minutes for a full build of just the Mobot software, not the container. So, and then it took 101 minutes and 40 seconds with a load average of between 4 and 7, and there was a good deal of swapping, as indicated by the K-swap-D process, consuming significant CPU cycles, shown by top. So all that to say that the RPi 0 can run ROS 1 and ROS 2. It's when you go and build big libraries, it gets really slow. But I did find that I did run my Robo Columbus code driving the simulator. That I ran the simulator on the laptop because it's just not realistic to run Gazebo and the whole robot simulation, physics simulation on an RPi. But the Robo Columbus driving code was running in a ROS1 Docker on the RPi 0, and it took about 30% of a CPU. And there are 4 CPUs on the board, so I'm confident that RPi 0 can actually be a decent robot controller. And I was gratified to hear, I've forgotten the gentleman's name who presented the walking robot earlier.
Oh, John. Yeah.
Sorry?
John.
Was it?
Yeah, John. Say he's got an RPi 0 running all of those legs. So that kind of was, I guess, experimental validation that to support this assertion.
You're really talking about a 02 though, right?
Yeah, a 02W.
64-bit.
Oh, okay. Yeah.
Okay, because that processor is a big step up from original
The 0.
Original 0 only had 1 core, and it's
Two.
yeah.
Okay. Still, it's only $15. And
So you made a comment. You made a comment that caught my attention. And let me rephrase it to see if I understand it correctly. You said if you know you're going to be running Docker, using the Pi OS is a preferred OS versus Ubuntu?
I believe so, because I have tried Ubuntu on a Raspberry Pi 4, and I ended up, it was difficult to get the serial ports working, and then I lost the recipe and I couldn't make them work anymore, and then it was difficult to get it to boot off of SSD, and I lost the recipe and couldn't do that anymore either. And there were different, because I was running ROS1, I was running Ubuntu 20.4, and really that's getting to be an old OS anymore. And you can run the latest Raspberry Pi OS. And in my mind, that's a better choice because you get like weekly updates. For example, a couple of weeks ago, I went to put a Raspberry Pi OS image on it, and the only one available for the Raspberry Pi 02W was a 32-bit OS, the ARM HF. So I went down that path for a while and ended up, I would have needed to do a source code install of ROS, and I couldn't because the tools weren't available for the ARM HF. And then by the time I came back after a couple of weeks, they'd released a Raspberry Pi OS 64-bit, the Bullseye release of Raspberry Pi OS for RPi 02W. And so, my point here is that I think you're wise to stay with the OS that's built for the board and run ROS in a Docker.
Yeah.
Did that address your question?
I'm at the other end of the spectrum. I have a Pi 5, and it does not support Ubuntu 22. It's only 23 and above because of the GPU. So I'm gravitating to using it with Docker. That's why I was asking the question. So I guess at this point I might just try ROS OS and run Docker.
Yes.
To get the ROS 2 running on the Raspberry 5.
Yes, that's a great use case, and Ubuntu 24.04 is going to come out early this year, and it'll be a candidate at some point to go onto my laptop, and then I won't be able to run ROS Humble anymore. And So generally, I think Docker is a really good way to go. And what I'm presenting here is what I think are some significant advances in getting Docker containers that are running ROS1 and ROS2 to run on x86 and Raspberry Pis. And I have found that the Raspberry, the ROS1 RPi and ROS2 RPi both do run on both the Raspberry Pi 4 and the Raspberry Pi 02W. So, it's cross-platform. And much of this work has involved building the Docker file, which is where you put all of the stuff that you want installed in the ROS layer that I'm building here. So I start from ARM64 V8 /ROS, and then ROS Humble /ROS base, and then start adding stuff that you want, like the desktop and the Swiri console and Terminator, so you can have multiple windows, or a terminal split into multiple sub-windows, and the internet tools and all the tooling that you need. And then the user, myself as a user, and SSH configs, so I can SSH into it, and so forth. So I've tripped over about every rock that there is in this path, and really mostly in service of my own interests of being able to use my current software but migrate over time to ROS2 for my robot, on both the Raspberry Pis and my laptop, independent of the OS that's running on those platforms. And so, but sort of partly what was in the back of my mind was that maybe there's interest in so at one of the DPRG meetings prior to Christmas, people were asking about a robot that Doug had presented that was partly ROS or used ROS2, and they were saying, "Is this a good way to learn ROS2?" And I said, "No, not really, and I don't believe it is. It's maybe a perfectly fine robot, but it's not a good way to run ROS2." And so I was wondering, and just throwing this out for the first time here, if there's interest within the group in perhaps some workshops covering Docker and ROS2, like setting up an RPi and setting up Docker, all that stuff within the Docker file, and how to launch the containers and prune them and delete them, and how to configure your PC to run them and configure a RPi to run them. And then the ROS2, I've been going through the tutorials, and I'm happy to report that ROS2 uses concepts almost the same, exactly the same concepts as ROS1. So it's very, very familiar to me. Some minor changes in some of the build procedures and launch procedures. But I was thinking, how could this be useful to DPRG folks who might be interested in ROS2, but I don't necessarily want to do. I only ever want to do something that has use. I don't want to do things that have no use. And one thing that's useful is, I thought might be generally broadly useful to people would be, DPRG folks tend to have a robot microcontroller like the kind of architecture that Clem was just describing, but they could potentially export telemetry. On my robot, I'm going to use micro ROS over here on the microcontroller. But there could be, proprietary telemetry over to a telemetry RPi that could then provide access to cool tools like Plot Juggler and other ROS tools. And so just to finish up this thought by switching to, before I ask for comments here, feedback, just to share, nope, that's not the one I want to share. It's this one. So are you seeing a Plot Juggler window here?
Oh yeah.
Yep. So Plot Juggler is one of the coolest tools, and I haven't seen anything this good. So what we've got here, this was my winning Robo Columbus run. So there's about 100 yards down here to this cone down here, and about another 80 or so over to this cone here. And so you can scroll through a bag file and see where the robot was in XY space. And what's interesting was when I pulled up this plot just to have a look at how the robot did, I ran into this spot right here in the nav debug / bearing, and all of a sudden bearing that had been running along nice and steadily, this is the bearing to the next waypoint, suddenly started to go crazy and oscillate. It looks like it's alternating between a real reading and minus 2.5 reading. I was like, what the heck is going on there? And
is that scale in meters, or is it just a relative scale? Or
that's in degrees.
So this scale, the XY plot, is in meters. So it went from minus 40 at the start to about plus 50 at the first cone, and from about 0 in the X direction, it went straight north to about 60 in the X direction to the second cone. That one's in meters, and can also plot X. Drop this on, and Y. So there's X and Y in meters. And we can plot the speed, linear speed. There's the speed. So anyway, very powerful tool. And I thought maybe ROS DPRG people might be interested in enabling the use of powerful tools like this through the use of a telemetry board and maybe learning ROS2 in the process. So anyway, I'll stop presenting there and just...
Well, wait a minute. You can't leave us there. You got to tell us what happened.
Yeah, what happened here? It's a mystery.
He won the mug. What else matters?
What have I got to tell you, Doug?
Well,
what were the crazy oscillations there?
Well, yeah.
So I believe, so I haven't actually found it, but I believe, so I made up a language where, well, actually, I'll show you. I do believe I know where it's happening. I
Have
just
you tried opening and closing some doors?
I haven't found out why, but this. Oh, rats. Let me just stop presenting that one and present this window. Test full. So this is the my own language that ran Mobot during the contest. So I asked it to run a program called runner.py that takes a set of arguments, the first of which is nav, and then pairs of waypoints. So it should navigate to 7,22 in the east and north direction, then 0,40, then 3,64. So this is where you saw it if you were there watching it, Doug, you saw it pause and then change direction. These were where it was achieving these waypoints and then moving on. Well, where it goes to nav 1189 is where the first of those double emissions of status start. So I think it's something to do with these, and then as it executes more commands to get more and more of those bursts of publications. So I think something in this program is not closing out these commands, but I haven't found what it is yet. But now I believe I know how to reproduce it in simulation, and then I can debug it from there.
Okay.
So I don't know. I'm headed down that path largely for my own purposes, because I want to end up with ROS2 on Mobot and MicroROS on Mobot's microcontroller. But I thought there could be, it seemed like, at least the meeting before Christmas, that maybe there was some interest in learning some ROS2, and I thought with a as cheap as RPi-0 2W is, and the fact that it's capable of running a Docker running ROS2, it might be an interesting thing to hold some series of workshops on, and so I just want to ask for feedback.
Yeah.
You're talking about a ROS2 with Docker, right?
Correct.
Yes, I'm interested in that.
Well, I mean, just to have a canned thing that like follow along by numbers and be able to get a telemetry gathering visualization system as an example. I mean, and then that sounds like a basis which maybe you want to add controls or loops or other objects. I mean, that sounds like a great, at least for my bench, it's a great gap filler to get started.
Yeah, and I wouldn't worry about using a W2. I mean, because yeah, it's $15, but Pi 4s are now pretty much back in stock. So, you could just go with a Pi 4 and save the time.
Yeah.
Yeah, it's the Docker aspect that's most interesting to me. Using Docker is what's most interesting to me. Because I have a Pi 5. I can't run ROS2 on it right now.
Yeah.
Right.
Yeah.
Exactly.
And you're right. That might, Brandon, that, maybe later on we could try it with Pi 5s too, because mine's still on order. I haven't been able to get one. And I wanted to ask you this question, though. On your R4, how many gigs of memory did you have on it? Was it a 2 or a 4? Okay, so you had an 8. Okay, that's fine. I just wanted to know what you said a half was too little.
Right. If people have a Raspberry Pi 3, it's got a gig, so it's probably a viable. What I found was when I was building big C libraries. Let me just get back to the data. I would see on the 0, I would see it. Hang on, let me just make sure I don't tell any lies. Free memory. So you've got 500 megs of memory on the 0, Pi 0. Free memory, as shown by top, frequently dropped below 100 megabytes, maybe down into 60, 80 megabytes. And it occasionally used up to 400 megabytes of swap. And that's really what caused it to just slow down, because it would just swap itself crazy while compiling those big libraries.
Did you have an SSD on it? I'm just curious.
No, this was on using an SD card.
Okay, yeah, so that's even worse.
Yeah, I don't have an SSD for the RPi Zero.
Mm-hmm.
Yeah, so okay, sounds like there's interest. Brandon, if you're interested in using Docker, you can get going, I believe, today, and I'd be interested in in fixing any stuff that you find that wrong documentation or stuff that doesn't work, whatever. If you clone my Ross Docker's repo from GitHub,
can you put? It's a link in the link in the
yeah,
chat.
yeah. If you put the link in I could trace it down.
Yeah. Do that.
Well, right now, I'm working with Ross 2 on a Raspberry Pi with a native Ubuntu on it, and also my dev machine is a native is Ubuntu also, and it seems to work pretty good, but I'm curious about Docker. That might be useful for collaboration and stuff.
Yeah. I mean, if you're happy with Ubuntu on the RPi, as long as it stays stable. I was trying to make it run on 20.04, and I think 22.04 made some steps forward in terms of running on an RPi. So you might be good. So anyway.
Yeah. So I'm using 2204 and Humble. I was wondering if I should use Iron, but I'm just using Humble.
So anyway, just to say that the repo, I put instructions there, and I've put other instructions. Let me just post another link and show you and share where that is. My home site has more details on the specifics. So I'll share that home page out. So if you go to Mobot and you scroll right down, and down at the bottom is the RPi4 and RPi02W configuration. And so there are instructions here on what you want to do inside of RPi Imager, and we'll skip over the SSD boot notes. I did do comparisons of I/O performance of the RPi4 and the RPi0. There's the firmware config for enabling the UART, so you can get into it when you don't have a monitor and keyboard available. And then in the Raspberry Pi OS configuration, there's instructions for which packages to upgrade and how to install Tiger VNC and GitHub, and get your SSH to work so you can SSH without giving a password, and then packages you want, VNC. I didn't put Firefox in this time. Miniterm, git config, and then the Docker installation configuration. Here are the instructions on how to get Docker installed using these instructions, and then you verify it, and then you run the Docker post install per these instructions, and then you add this to the bash RC on your RPi. Anyway, I figured that'd be the kind of stuff that would be maybe. I was thinking for people who might want, for anyone who wants to do this, I was envisioning and give me feedback on this, but envisioning a workshop type format. So not as part of the weekly meeting, but at some mutually agreed time, evening, off, separate from the RBNV, and we can do makeups for people who, if someone can't do it or gets stuck. Because one of the things that'll probably happen is someone will find, they can't get the thing to boot. Why not? Well, you don't want to hold everyone up because one person can't get it to boot. So, I'd be happy to work with people offline, one-on-one, to get that going. But Brandon, sounds like you're Brendan, I'm sorry. Sounds like you're pretty far down the RPI path, and so if you want to drop me a note, and maybe we can share thoughts on.
Well, I'm learning, so I've got a lot of robotics background, but the ROS and Pi are the new aspects of this go round. But I've got two ROS 4s. One's a development board, one's a ROS MI4 in my robot. But I have a base station here that's going to be my remote brains. It's a ROS 5. It's a Pi 5. So it's two Pi 4s and a Pi 5.
Yeah.
And then I got a virtual Ubuntu 22.04 on my Windows machine.
Right. And the good thing about Docker containers, I'm just really pumped on Docker containers, because the good thing is, when having installed, some of you have installed ROS on a laptop or a Pi, and you put all these packages in, and then you forget some of them, you don't write them necessarily all down, and then if you want to wipe the thing, you got to do all that again. And with Dockers, the recipe is in that Docker file, and you just type Docker build, and you go away for half an hour, and when you come back, it's there. It's just like ready to run.
Yeah, I'm very interested in that.
Okay. Well, thanks for the feedback, guys. I'll think about some more. It's sort of I feel like it's at the 95% stage at the moment. Not everything works as well as I wish it would. For example, Plot Juggler won't run under Docker yet, so I'm working on stuff like that. But the basic stuff runs, and I'd be happy to lead a group of us through that. So maybe over the next week or two, let me ask one question. What about the laptop OS? How many of you use Windows and would want to use Windows as a laptop or as a dev laptop OS? But
I also wouldn't mind learning the old make an Ubuntu VM within Windows method, if that's a good idea.
Yeah, I found out the VNC does not work through Windows very well, but if you use a virtual machine of Ubuntu, you can VNC into your Pis just effortlessly.
And I know modern Windows machines seem to have the VMs running straight to the bare metal, so you don't have a performance loss.
Yeah, so that's
right.
So that I was playing around with that today. I've been primarily using Oracle VirtualBox, but I started playing around with what's the Microsoft version? Hyper-V. Hyper-V is one built into Microsoft. I'm playing with that on my home lab server. It's working pretty well too.
There's another solution that is a possibility, and I don't want to discount or disparage the use of VMs at all, other than they are slow. I've used VMs, used VirtualBox, and they are slow. And ROS 2 supports, or I should say, Windows supports Docker, and ROS 2 supposedly supports Windows. I feel like the support is kind of tier 3, because apparently you need to build ROS from source to get it to run on Windows. But I'm thinking a solution for Windows would be to run a Docker container with ROS 2 in it on Windows.
That would be interesting. Yeah.
Yeah, it seems like if you can figure out how to do Docker, you kind of, don't worry about the underlying OS as much.
Well,
if you learn the skills to run Docker on any platform, you can do it on Windows, Linux.
It's not quite that straightforward. I wish it was.
I know.
Apparently, you have to install Linux. I'm sorry. What's it? WSL, Windows System for Linux.
I'm understanding your Docker package has to be aware of what OS it's running on.
Yeah. So are you all running Windows 10?
10 and 11.
10 or 11?
Depending on which
one. I don't think Docker runs on Windows 11, so that's an issue.
Yeah, that's right. I think you have to. I'm on my Windows 11 machine. I'm running a virtual machine, Docker on it.
Yeah.
So maybe it's time to grab an old machine and put Ubuntu on it.
Yeah, this one I just do boot it, and I boot either Windows or Ubuntu, depending on whether I'm doing robotic stuff or not.
Well, what I'm really looking for,
fine under Windows 10. Oracle or Hyper-V seem to work just fine for Ubuntu on Windows 10.
So I'm looking for guidance from you guys who are potentially interested in this workshop series as to whether I should try and pioneer a path to put ROS 2 in Docker on Windows 10 specifically.
The robots won't be running Windows.
Right.
It's
What
Linux.
do you mean that robots will not be running Windows?
Will not be running Windows, right?
Correct.
So I'd Windows is nice, but if you're getting down to the robot, it's going to be Linux.
Right. And it's ROS 2 all the way. My thinking in proposing this is, is really about using the tools, so opening bag files and exploring them, and getting responsive scrolling around in Plot Juggler, and so I don't know.
So like RViz and stuff like that.
Yeah.
So would this be like writing a URDF for your particular robot kind of course, or would it be just once you have that, how to use Docker to start it off?
I might offer to do URDF for people, but I'm not offering that right now. So it wouldn't be URDFs in RViz. You can just put a point where the robot is in RViz.
Okay, got it. Yeah, I was just curious what we're talking about. That's all.
I found came across a tool that's even better than RViz. It's like RViz on steroids, or almost like a combination of RViz and Plot Juggler. It's called Foxglove Studio, and it is a cool tool. In fact, let me just bring that up and share it. Foxglove Studio. It's built by people who used to work for cruise automation, so you know the kind of okay, where are we? Come on. That's not what I want.
What'd you call this?
Foxglove.
Glove.
I've heard of it. I think I've seen it.
Foxglove.dev. I don't want that. Let's taking to my, I'm going to get to the advertising, the cool video, cool graphic stuff. And it's taking me to my workshop. Okay, I might not be able to get it. Anyway, imagine a combination of RViz and Plot Juggler. The only thing it doesn't do that Plot Juggler does is the XY plotting, but it's got practically everything else that both of those products have. It's a really cool product.
Hey, Paul, can you put out a link to? Oh, somebody did. I got it.
Yeah, I found it.
Yeah. Yeah. Sorry about that. That link takes me to my workspace. It like doesn't take me to the the cool picture of like the car driving through the city and all the LiDAR. So, but it's really aimed at that kind of application. Self-driving cars and LiDARs and cameras and all that kind of jazz. So,
big toys.
Yeah. It's a big boy visualization program.
Is it open source or is it?
No, but they've got
mucho money.
No, they've got a free version for hobbyists.
Oh wow! Okay.
Yeah, they only start charging you when you start collaborating with team members. So on an individual basis, it's free. So it's like, wow, that's great.
Yeah.
So if you're antisocial like me, then it's free.
Exactly. Okay, well, maybe next week I've got some ideas jotted down on about the topics we might cover. Maybe we can include that in next week's discussion, and I'll think further along these lines. Sounds like I don't necessarily have to jump on running Windows, because you can run all the ROS tools, including the GUIs, on an RPi 4, and just get them through VNC.
Well, it sounds like a great idea, and it sounds like if you build it, they will come. They being us.
Well, thank you for your time, gentlemen, and your input.
And thank you for yours.
Yeah.
Thank you.
Well, we really ran late tonight.
There's a lot of people in the chat thanking for the great discussion, and yeah, when there's still 8 or 10 of us online, it talks to how good it is, huh?
Yeah. Good meeting. Good meeting.
Okay.
Okay. Thanks, everybody.
All right, gentlemen. It's probably time to call it a night.
Have a good week. We'll catch you later.
All right. Good night.
Night, everyone.
Night.